All over YouTube, there are thousands and thousands of React tutorials, but very rarely do you see a genuine modern React app built completely from scratch. So in this video, we're going to start from absolutely nothing, meaning a completely empty terminal to a production-ready React app. We'll use technologies like React Query, Tailwind, skeleton suspense loaders, API fetching, interactive maps, light mode and dark mode, responsive design so it looks great on this device, and this device, and basically everything you need in order to build a modern React app that looks and works great. I'm going to have very minimal editing of this video. It'll pretty much be a raw cut of me building out the entire project. It'll be split up into segments, so if there are certain parts you don't care about, or certain parts where you want to see exactly what I do, please feel free to skip around. You're not going to offend me. In the description, I'll link the GitHub to the project so you can clone the repo and check the whole thing out for yourself. Without wasting any more time, let's get right into it. Here's a quick snippet of the project that we're going to be building. It's a real-time weather dashboard where you can access the weather data at any latitude and longitude coordinates across the entire planet. We'll be using the Open Weather API to get all of this data and combine everything we know about React to make this a buttery smooth and highly functional React app. Let's get it. To create a new React app, go into your terminal, making sure you're in whichever folder you want this project to be in, and run npm create vite at latest. Vite is a build tool that takes all of your React files and builds them into the actual app that you see on a web page. This create vite at latest command will create a Vite project that gives us a great starting point. Once we've run this command, it'll ask us a couple of things. First, okay to proceed. We'll say Y for yes. It'll do that, ask for a project name. We'll just call this weather-project, something super simple. It'll ask for a framework. We'll say, of course, React. And for variants, we're going to choose TypeScript. Roll down Vite, for now, we'll say no. We don't really need that. And then with npm, we'll go ahead and say yes. And there we go. It just created our Vite app, and it actually just launched it. If we control-click the link that it gave us, it'll take us to this page here, and this is our web app. At least, it's the starting point. To actually get into your code, go to Open Folder and open the folder that you just created. So whatever project name you gave it, go ahead and open that folder. And this will actually open up your code. Let's zoom this out so we can see a little better. And also just collapse this agent window on the right. This extremely simple process of running npm create vite at latest is my preferred way of getting your React app up and running super quickly, so it's always what I recommend to anyone watching. Vite is pretty much the industry standard now, as it's a fast and super efficient build tool, so setting up this Vite project with this boilerplate code is a perfect way to start a React app. All projects that you create with Vite are going to look something like this. I'll zoom in so you can see a little better. If we look in our file explorer over here to the left, you'll see we have a couple of files and folders. Most of these config files down here you don't have to worry about too much right now. They're just settings for the overall project. What we really care about overall is this source folder, which is where we have all of our React code. React apps built with Vite will always have main.tsx as the entry point to the React code, so it all starts here in this file. We render out this app component, which if we go into it, is the code that we actually see on this page over here on the right. So main.tsx is the entry point for our React app, but app.tsx is the primary component that we're going to be working in. Vite has hot module reloading, meaning if I change anything in the JSX here, I add a bunch of characters and I save the file, it'll update in real time on the page. We've got a couple other random things on here like some anchors, images, divs, whatever, but as promised, we're going to start from a completely clean slate. So let's actually take all of this, completely wipe it out, Control S, and we'll start completely from scratch with nothing but a blank page over here on the right, which also means I don't really care about this count and set count state, so I'll get rid of that as well. If we look, we have this app.css file, which if we go ahead and open it, you can see we have some boilerplate CSS, but honestly, I really don't care about it. So let's go in here, app.css, and let's just completely delete it. So we'll also remove this import so there's no weird import errors. Go ahead and save it, and we've completely obliterated the app.css file. Lastly, we have this index.css, which again just has some more boilerplate. There's a bunch of random anchor, body, button, and some animation stuff here at the bottom in this CSS file that again, we don't really care about. So let's actually delete everything from here up to here. I don't want to completely get rid of root just yet because we might use some of this, but let's get rid of all that and go ahead and save it. And now we've also wiped out that CSS file. We'll still use some of this basic stuff like this background color for now and some of this font stuff because this index.css file is imported directly into main.tsx, meaning anywhere we have any React components in our code, we'll use the CSS file. So this is fine for now. Let's go ahead and leave it alone. We'll close it, and let's go back to app.tsx, which again is the component that we actually care about. Right now, our app on the right is running out this app component, which obviously is nothing because this app component is nothing. And we have really no CSS besides a few things that I just saved from index CSS, so we're starting completely from a blank slate. We don't have a template, no weird style sheet stuff going on, not a bunch of stuff we're copying, just a completely blank page. Now is where the fun begins. Let's start by talking about some of the infrastructure for this app. There are two technologies or packages aside from React itself that are going to make up the core of this project. One for styling, and the other one for data fetching. For styling, we're going to use Tailwind, and for data fetching, we're going to use Tanstack query, which is the same thing as React query. So before we get too far into our coding, I want to get the infrastructure for these two things set up right now so that we don't have to worry about it later. So let's start with Tailwind. If we navigate to Tailwind's website and go to the installation tab, the default installation is for Vite, so we can easily just follow this guide. We've already created our project using the npm create v-latest command, so we can go ahead and skip this first step. Next, it tells us to install Tailwind CSS and at Tailwind CSS /vite. We'll go ahead and take this command, copy it, paste it over into our terminal, and run that. Next, it tells us to add this Tailwind CSS to our Vite plugins. So if we go to our files, we go over to our vite.config.ts, we go ahead and look in here. We already have React as a plugin, so let's just add Tailwind CSS as a plugin, just like this, and go ahead and save this file. Next, it'll tell us to import Tailwind CSS into our index.css file, so we'll take this import here, go back to index.css right here, and go ahead and just add this import at the very top of the file, and go ahead and save this file. And then all we have to do is restart our build server just in case, so we'll terminate this, make sure to run npm run dev again, which again is the run command. That restarts our build server, and now we are actually free to use Tailwind in our app. So we can go ahead and close these, and that is all we need to install Tailwind. It's a super simple setup process. To test this and make sure it works, if we go into app here, let's just make this a div. I'm going to give it a class name of size 32, and then bgred500. This is the whole point of Tailwind. You can write styles inline like this instead of having to have dedicated CSS files. If I go ahead and save it, you can see we have this red square up here on our screen, so Tailwind is working perfectly. I can change these in Tailwind, start messing with it, and everything I do will be Tailwind valid because we set it up really easily. Cool, so we know Tailwind works exactly like it should. If you're not super familiar with Tailwind, just know it's a way of writing super nice and convenient styles inside the class name of your JSX elements, instead of just spamming CSS files and random classes everywhere and getting messy. We'll be using it throughout this entire video. Now that we have Tailwind added for the data fetching part, we're going to add Tanstack query, which some people still call React query, into our project. I have 2 whole videos on Tanstack query. If you don't know how it works, that I'd suggest checking out. But otherwise, I'll assume you have at least a foundational understanding of it as we work through this video. This library is also very, very easy to add, just like Tailwind. If we go to the installation docs for tanstackquery.com, we can look at the npmi command to install it. So let's go ahead and copy this, go into our terminal, and install Tanstack query into our project. With that done, there's only one more thing that we need to do. If we go back to main.tsx, which again is the entry point for our app, we need to set up our query client in this file because Tanstack needs that in order to have context to the queries that we're going to be making. So in main.tsx, we'll first want to make a new query client. To do that, we'll just say const query client equals new query client, just like this. That is from Tanstack, and we're intentionally doing this outside of any sort of React component because we only want it to be created once. We don't want it to have any sort of re-rendering or nothing involving the React lifecycle. And then what we'll do is highlight our app here, Control-Shift-P, type a wrap, and then we're going to wrap this right here with a query client provider, just like this. We'll import this also from Tanstack like this, and this component takes in a single prop, which is just called client, where we can pass in our query client. This query client provider right here works just like any other provider you would use with context in React. It is just what Tanstack query requires to have a functional query client. Now that's done, we can close out of this file, and we've just got 2 huge foundational steps out of the way. We have our styling component installed and our data fetching component installed. So we're ready to go and use both. Speaking of data fetching, how are we actually going to do that? I mean, I know how to fetch with Tanstack query, but what data are we actually fetching? We want this weather dashboard to show real-time, up-to-date factual data on our page, not just some mumbo-jumbo, hard-coded garbage. This is where Open Weather comes in. This whole entire project is not possible without them. Open Weather is a giant API that allows us to get all sorts of accurate, real-time, and historical weather information. OpenWeatherMap.org is where we can find all the information about them, including their API docs. If we open the menu over here and go to the API page, I can start scrolling and see all sorts of different types of information that we can get that's from weather. So current weather, hourly, daily. You can see there's bulk downloads for stuff, solar irradiance, history, weather maps, air pollution, and all sorts of other APIs that we can use from this site. Some of these APIs are locked behind paywalls, but the ones that we're going to be using are completely free. The primary one that we're going to be looking at is this one call API 3.0, which is their main one. Basically what it will do is it will give us the current weather at any location, the hourly forecast, daily forecast, minutely forecast, and a bunch of other stuff. We're not going to worry about minutely in this video, but we will be using the current, daily, and hourly weather information to populate stuff on our page. If we click into the API docs right here, I can show you exactly how it works. If we scroll down, it'll tell us exactly how to make an API call with this link right here. I can zoom in so it's a bit easier to see, but it's just this URL that it gives us. All we need to do is call this, pass in latitude and longitude coordinates, and give them our API key. So basically, how we'll be able to click on different areas of the globe and get the weather information for anywhere on the entire planet Earth is through these latitude and longitude arguments that you can pass into this URL. And we'll have some other customization options like exclude or whatnot that we'll also take a look at. But for right now, let's focus on this API key right here. If you try to hit this whole URL right here, this API, with no API key, we're going to get an error 400 telling us that we're forbidden from accessing it. If you've worked with APIs in the past and you're familiar with them, you know this is pretty much how all APIs work. If you want to use the service, you have to get a key through the service first that you can pass through to each API call. To get an API key for Open Weather, all you have to do is click on this API key tab right here. If you have not made an account with Open Weather or you've never used them before, go ahead and create an account right now because you can't get to this page without an account. Before you create an API key, it'll most likely ask for payment information as well, but don't worry, you don't have to pay a single dime. Everything that I'm doing in this video is completely on the free tier, up to 2,000 calls per day. So as long as you're not spamming 2,000 plus calls every single day, which you definitely shouldn't be, it's completely free. They just want the payment information in case you go over. Once you've gotten through all the logistics like creating your account and you get to this API keys tab, you should be able to generate an API key. My API key is right here. So what I'll do is go ahead and copy this entire key because we'll be needing it in just a second. What I will usually do for storing API keys or other sensitive information is go to my file explorer and at the root level, create a new file that I usually call .env.local, just like this, where I'm going to be storing my private environment variables. You don't want API keys leaking out to the public because then people could spam with your key and end up running up your credit card. So it's usually something that you want to hide. And before anybody tries to get funny and run up my credit card with this key, I will be destroying it before I post the video, so don't think about it. If we take a quick look at our gitignore file, you can see that any file that has this .local on it is going to be hidden from Git. So this .env.local is not going to be pushed up, so we don't have to worry about it being public. Luckily for us, Vite has a very simple way of doing environment variables. We just have to start the name with Vite and then Vite will recognize it. So for this, we'll just say Vite underscore API underscore key equals quotes, and then we'll paste in the API key that we copied from Open Weather, and then go ahead and save this file. Now anywhere we need to access our API key, we can use Vite's environment variable system to use this value in a safe and protected way. Okay, now that we have that, let's take a second to think about what we should do next. We've created the basis of our React app, installing Tailwind and TanStack Query in the process, so we've got a blank app page that we can start working on. We also got an API key from Open Weather, which permits us to call their weather API to get the information that we'll be populating our page with. In my opinion, the next logical step here would be to set up some functions that we can easily call in our React components that will fetch us the API data from this link right here from Open Weather. So let's go ahead and do that. We'll start with this API call here. We'll write a function that will take in latitude and longitude as arguments, and then what it will return will be the actual weather data. If we want to see what the return value is going to look like, we can scroll down to here where it gives us the example of an API response, and we know that this function that we call is going to return something of this format. So again, it'll have stuff like the latitude, longitude, time zone, current weather data, minutely, hourly, and a bunch of other stuff. So just to reiterate, this function will take in latitude and longitude as arguments, and it will spit back out the weather data for whatever we pass into it. Let's go ahead and do that. Now, normally I would want to split up API functions into different files and folders, but since we'll only use a handful of different open weather API calls, I'm just going to make a single file inside of source here that I will just call api.ts. And in here is where we'll make our functions that interact with open weather. The first one will be the one that we just talked about. So let's just say it's going to be a function. We'll say export async function, and I will call it getWeather. Let's look back over at our page over here and take this exact link right here. So I'll go ahead and copy this. Then we'll go back over to our code. Let's say const results, and we're going to say equals await fetch quotes, and we'll pass in this link. And actually, instead of using quotes, we're going to use template quotes so we can inject some stuff in there, just like this, and this will be our basic setup. If you've interacted with any API or backend before, you know that fetch is the standard way in JavaScript of interacting with HTTP to get responses like that. If you want to, you can also use something like Axios, but for this video, we're going to keep things simple and just use fetch. So we're going to fetch, and we're going to give it the open weather API link right here. Like most fetch requests, we'll want to parse this into JSON format. So let's go up here, and let's just say const data equals await res.json to parse it into JSON format. Again, our API response, if we look over here, is going to be an object with a bunch of stuff. And if you look closely, this actually is in JSON format, which makes our life a lot easier. Last thing we'll do is return data. And this function is essentially done for the most part. Very, very simple. All we're doing is fetching the open weather link, parsing that as JSON, and then returning it. What this means is if all goes well, I took this exact link right here and pasted it in here. So if I ran this in my app, I should get this exact response object. Obviously the numbers would be a bit different because it's probably a different point of time that I'm doing this, but you get the picture. There's a few things we need to make our getWeather function actually work properly. The first obvious problem is that this is just a hard-coded link with hard-coded latitude and longitude. In our case, we want to be able to pass in latitude and longitude, not just hard-code the value. So let's give this function some arguments to take these in. You can do this in two separate arguments if you want, but I'm just going to put them inside of a single object, so I only need to pass in one thing. So I'll just say an object expecting latitude and longitude. And to make TypeScript happy, we'll say its type is going to be latitude, which is a number, and longitude, which is also a number. All that we're saying here is for getWeather, we're expecting a single argument, an object, where we are destructuring latitude and longitude. If we want to use it in our API call, because we use the template quotes here, we can inject JavaScript directly into the string. So right here where it says latitude, let's take this, replace it with $ brackets, and we can put in latitude like this. And for longitude, we will do the exact same thing. Now, the latitude and longitude that this API calls will be directly decided by whatever latitude and longitude we pass into this function. For the last thing, we need to do this exact same thing for our API key. And this is where the environment variable that we just made comes into play. At the very top of this file, but outside of this function, let's make a variable for our environment variable. So all I will do is say const API key equals. To properly use Vite's environment variable system, all we have to do is import .meta.env. And then whatever the name of our environment variable is. We named ours v_API_key just like this. So now this variable has our API key. If we go back real quick to our env.local, you can see this is v_API key. So we'll just want to make sure this matches 1-to-1 right here. So now anywhere where you want to use our API key, we can just use this const right here. What that means is in our fetch over here, instead of doing this random app ID thing, all we have to do is get rid of this, make this also $curly brackets, and pass in API key just like this. Now we're not only passing through latitude and longitude from our function arguments, but we're also passing in our API key that we're storing in our environment variables. And now this function is good to go. Now that we have the essentials, this function getWeather will actually work now and return to us weather data from open weather, assuming we pass in valid latitude and longitude coordinates. However, there's one more quick thing I want to change. First of all, I prefer to have my weather units in Fahrenheit. So after longitude here, I'm actually going to make another argument. I'm going to say %units equals imperial, just like this. If we scroll up in the API, it mentions this. If you look here in units, you can pass in standard, metric, or imperial. So I'm going to use imperial. But for your own app, feel free to use whatever you like. There's also this exclude right here. I mentioned that we're not going to be using the minutely data, so we might as well exclude that. So in addition to doing the units imperial, I'm gonna add another one. I'll say ampersand exclude equals minutely, just like this. And we're also not going to use alerts, so let's do comma separated and go ahead and exclude that as well. So now we've customized this function to do what we want and have all the essential things like passing in latitude and longitude and returning the data that open weather gives us back. And now that that's done, we should actually be good to go for this function. We can take in latitude and longitude. We fetch the open weather using those coordinates by passing those in to the fetch call, while also passing in our API key. We parse that data as JSON, and then we return it, so that we can use it in our React components. Let's make sure this file is saved, and now close it and head back over to our app and take this function for a test drive. In our app component, we're going to make a use query for this API call to see if it's actually working. So up here at the top, how we normally do use queries with tanstack query is we'll say const, we'll extract data out, equals use query, and then we need to pass in a query key and a query function. We'll make sure this is imported from tanstack. So for our query key, we don't really care for right now. I'm just going to say weather. And then for our query function, this is just going to be the function that we just wrote. So we'll say parentheses like this, call get weather. And like we just did with get weather, we'll import it. Remember that it is expecting a single argument that's an object that contains a lat property and a lon property. So right here, we'll just say lat, 50. And also lon 50, just like this. We're just hard coding them for right now to make sure it works as expected. And then in our JSX, to make this super simple, let's get rid of this div right here. And let's just go in here and let's just JSON.stringify data. That way we can at least see it on the page. Let's go ahead and save this now and head over to our page. And we can see, boom, we have this huge wall of text that now has a bunch of weather data. I'm not going to individually parse through everything in this massive text wall, but if you look at the very top right here, you can see the response that open weather gives us at least says lat 50 and lon 50, so we know it's the right coordinates, which gives us a time zone and an area of somewhere in Asia. If we go back into our code here, and instead of doing 50-50, let's do 10-25, for example. Go ahead and save it, refresh this page, and you can see now we have lat 10 and lon 25, which is somewhere in Africa. This stringified data is obviously super hard to read because this is not really, the intended way of printing all this out. But if we go over here, right click inspect, and at least open up our network tab, at least open up the network tab here, go ahead and refresh this and look at this. You can see we get it all in a nice JSON format, so it's a bit easier to read if you want to see what's going on. If I just zoom this in a little bit, you can see we have, again, the lat lon, the time zone. We have the current weather data, so stuff like the sunrise time, sunset time. We have the temperature, we have the dew point, visibility, all this other stuff that pertains to the current weather information. Then we have hourly, which is an array of all the hourly forecast data. So this would be the forecast for the first hour, forecast for the second hour. You get the picture. And then if we actually, let's say, collapse this here, you can see next we have our daily data, which is pretty much the same thing. It's an array where each object represents one day. So this is day 1 of our forecast. Here is the second day, same thing. And I think you kind of get the picture on what all this data is. This is a hugely important part of our app that we just got out of the way. Our React app is now interfacing with an external API, grabbing the appropriate weather data depending on what we pass into the getWeather function. So this is super cool. It's a huge part of a React app that we just dealt with. Before we go any farther, however, we should fix something. If we go over to data here and we hover it, it's going to say the type is of type any. And this, for one, is completely expected. Whenever you make an API call and then you parse it as JSON and then just return it, because you're parsing just pretty much a raw response string as JSON and returning it, TypeScript really has zero way of inferring what the actual data type looks like. Working with data that has type any is generally a big no-no with modern TypeScript apps, primarily because it makes it so easy to try and access things that don't actually exist, and it just leads to a lot of potential errors. If you've used quite a bit of TypeScript, you know that having smart types where you can get IntelliSense and you can know what properties exist and what you can and can't do is super helpful as a developer, and lacking it makes developing 10 times harder. So let's fix this type any and make sure data is the actual response type that matches what we're seeing over here in the network tab. The way that I prefer to do this is by using Zod. If you don't know about Zod, it's basically a type validation library that will ensure all of your API calls are typed properly, so you don't have to work with type any everywhere in your code. It'll also throw errors if your API response doesn't match the type that you give it to ensure 100% type safety. This isn't hard to set up at all. If we go to the Zod docs, it tells us to install it. All we have to do is run npm install Zod. So if we go into our terminal, let's just run that here and install Zod into our project. And then what I will typically do is in our source folder, I will create another folder that I will call schemas. And in here, I can put all of my Zod schemas. If you want to know how Zod works, let me show you real quick. In this file, I'll make a new schema. I will just say weather schema.ts, just like this. Basically, to make a Zod schema, all you have to do, if you want to make an object, is say something like z.object. If you want to make an array, z.array, string, z.string, you get the picture. Basically, what we'll have to do with Zod is go to our API and find what the response is going to look like. So for open weather, it's going to look something like this. And then we'll have to make a schema that matches all the types. So it'll be an object that has, for example, latitude, which is a number, so z.number in Zod. Longitude is also a number. America/Chicago is a string, so z.string, and you get the picture. Basically, we're just building out a Zod schema to match the exact shape of the open weather response. I'll be honest, I'm super lazy, so instead of going hand by hand and going every single one of these properties and then making a schema thing for it, what would be easier is just to use something like ChatGPT to generate a schema real quick. What I'm going to do is actually copy this entire example response here. So we'll go ahead and just copy this entire sample response object, go to ChatGPT, paste that in here. I'm going to say, please make me a Zod schema that matches this exact shape, minus, I don't want minutely and alerts. So I'll do this, and it should spit out a schema that pretty much matches the exact shape. So we're going to take this, actually exactly at face value. Let's see, we got all this. Yeah, so we'll take this, copy it, and in weather schema, let's just paste that entire thing in. So it's 100 lines, a lot of stuff, but again, doing this by hand is super tedious, and I don't recommend doing it. I'd rather just use something like ChatGPT to do it for me. So if we go ahead and save this, now we have a weather schema that is hopefully valid. If it's not valid, this will throw errors, so a good test would be to just plug it in and see if it works. Again, like I said, just quickly going over Zod. For each field, we'll just want to map to the Z type or the Zod type, so like z.string for time zone, z.number for the offset, dt is the time, so it's z.number, and you get the picture. Almost all of these are just numbers, so having z.number is super simple. So this actually isn't a crazy Zod schema, even though it looks a little bit complicated. So how to actually use a Zod schema is once we have our schema defined, we can go back to our API function, which is getWeather, and instead of just returning data like we are here, what we can actually do is we can return the weather schema. So we'll say weather schema, make sure we import that from the schema we just made, .parse, and then we pass in our data just like this. Now if we go ahead and save this, we're going to parse through our schema, and we're assuming that data is going to match this schema shape. So if we go over to app now, and we hover over data, now data should be the exact correct type. If we go ahead and head over to our page here, and just refresh this, it looks like we're not getting any breaking errors, so I think it's safe to assume for right now that this schema is right. Hopefully ChatGPT didn't just sell us short, and it gave us a correct schema. If it's wrong for whatever reason, we'll have to correct it going forward. We're not going to get any sort of weird type any, and by doing this, we're likely going to avoid a bunch of future type issues. Anywhere now in React land that we want to use this data variable, we can use IntelliSense to know what properties we can and can't access. For example, if I want to access the current weather data, I try and do something like data.whatever. IntelliSense now knows that I can access current, daily, hourly, or any of these things because data is typed properly. That's something that's going to be really helpful going forward. Sweet. Now that that's out of the way, what do we do next? Now that we have the current, hourly, and daily weather information fetched in the way that we want it to, I think the next logical step would be to create and style the components that are going to be holding this information. We could handle all the data fetching at once and then save all the styling till the very end. But sometimes doing that creates a monstrous amount of styling if you save it all to the end that I tend to not like very much. So we'll break down each section of the page with functionality and styling before moving on to the next section. Here's what I kind of figured and envisioned for our end product. We want to have a dashboard that has multiple cards on it, each of which holds weather information like hourly forecast, daily forecast, current weather, and you get the picture. It would make sense logically if we made this a single card component, and then the inner content of each card would just be the card's children. That way we have a shareable and reusable component that we can use for all of our stuff on our dashboard instead of having to rewrite a bunch of code. With that being said, let's go over to our File Explorer, and in our source folder, let's create a new folder called Components, where we're going to make all of our primary React components. And because we'll end up having different types of components, I'll make yet another folder inside of Components that I will just call Cards, just like this. And inside of Cards, let's make a component called card.tsx. If you have the React Shortcuts extension in VS Code, you can just type tsrfc, which stands for TypeScript React Functional Component, press enter, and it actually makes a skeleton for the component to avoid you having to write some of the boilerplate. Because we want each card on the dashboard to have the same outer styling, but be able to change the inner contents of it, we'll give this card a children prop, just like this, and instead of rendering our card right here, we will just render out children. And to make TypeScript happy, let's make sure we add it to our props. So we'll say children, which is of type React node. Just in case we need to add more customizable styling later, I want to make this div that holds the children different from the outermost div of this whole component. So if I highlight this whole div right here, Control-Shift-P, and type in wrap, I'm going to wrap it in a second div. And before we get any farther styling this component, let's see what these cards look like if we pass in some data that we already have. So let's go ahead and save this card right here. Let's go into app.tsx. Instead of rendering out data just being stringified, let's actually do something else. For now, what we're going to do is wrap this all in parentheses to make sure it is valid. And let's actually break this into 3 separate chunks here. So we'll render out card, just like this. And then let's copy and paste this twice. So we have 3 cards on our page. And then for each one of these cards, I'll pass in data that we're already getting from OpenWeather. So for this first one, what I'll do, I'll just pass in json.stringify, and I will pass in the current weather data, which if we hover data, is just data.current. So we'll do data.current. And then for these next 2 cards, I want to pass in hourly and daily. So I'll take this, copy and paste it. This will be data.hourly, because again, if we hover data here, we can see hourly is this array, and daily is the exact same thing, so we'll do data.daily. TypeScript will say these can possibly be undefined, so let's just add a question mark here to each of these to make TypeScript happy. And if we go ahead and save our page, now we'll have 3 cards for each type of data, both the current, hourly, and daily weather. Nothing really looks different right now since we haven't added any styles, obviously, but at least now our data is broken out into cards. So let's now go back to the card component we're working on and get some styling for this. So using Tailwind on this outermost div, let's give it a class name. And generally the first thing I like to add to new components, especially ones that have a background color and some borders, is padding. So we'll add a class name. We'll have P4 for padding, just to create some separation between the content and the outer edges. And then we'll also give it rounded XL to make it a little bit rounded. And we'll say BG Zinc 900. Go ahead and save it. And it still looks pretty horrible because you still can't really see any sort of separation, but we're at least getting somewhere. It still looks pretty horrible because there's just this massive text wall. So let's go to app, and instead of stringifying the entire thing like this, let's actually take that string and let's just take the first 100 characters for each one of these. So I'll add this .slice 0 to 100 for each one of our cards. And now it's a lot easier to see. We can at least see where each card begins and ends. This makes it a bit better, but let's actually make this fragment right here into a div and also give this a class name. And let's give each of the cards some separation. So we'll say flex call to put it in a column layout, and we'll give gap 8 to create even more separation between the cards. Go ahead and save it, and now that's even better. If we now go back to our card component, let's add a couple of more things. First and foremost, the majority of the time you have an element that is kind of close to the color of its background, like these cards here. Adding shadow can generally be good because it helps create a layered look. It makes the cards pop out against the background. So on these cards, we'll also just throw a shadow. We'll try MD for now, save it, and that creates just a slight separation against the background. Next up, let's think for a second about how we want these cards to actually be used. We know each of these cards is going to represent one portion of our data. So I'll have one card for current weather, one for hourly, and one for daily. How do we know which card is which just by looking at it? Well, the most clear way to show which card is which would be to give each card a title. That way the user knows which card they are actually looking at. If all the cards are going to have a title, it would make sense just to put that title in this card component here and have each render of this card pass down a title prop. That way we know what to display. So what I mean by that is inside card above the children here, let's make a header. We'll say header 2 for right now. And let's say is going to display title. Title will come from props. So we'll add title to our props here. And to make TypeScript happy, we'll say that title is going to be a string. To make this title actually stand out like a header, let's go on to this, give it a class name, and let's give it text 2XL, and then font semi-bold to give it a sort of title-ish look. And go ahead and save this card. If we now navigate back to our app, TypeScript is going to complain because we said title is a required prop, but we're not passing it in here. So for each one of these cards, let's actually pass in the title. For the current weather card, let's give it a title prop. And we'll just make these all strings. This will just say current weather. And then for our other two, let's do a similar thing. For the hourly card, instead of saying current weather, this will just say hourly forecast, and we'll specify that it is 48 hours. And then for our daily information, we will just put this as daily forecast. Go ahead and save it. And now our cards have a title on them, which we've just done through this title prop. Super simple. We need a bit more separation between the title and the actual information of the card. So let's go back to our card component here. And on this class name here, let's give it flex call, and gap 4. That'll make sure the title always appears above the children with a decent gap between them. Save it, and it looks a little bit better, some more separation. We may come back to this shared card component in a bit to change or add some things to it. But for now, let's actually work on getting the specific cards set up. So the daily card, hourly card, and the current card. So we'll go ahead and close out of these files, go back to our app, and let's ask ourselves, starting from daily forecast, what do we actually want this card to look like? Well, before we figure that out, preferably I wouldn't have to build out the entirely daily card within this app component, because then that would get a bit bloated. So let's actually make a new component for this card specifically. So inside of this cards folder that we already made, let's make a new file. We're just going to call it dailyforecast.tsx like this. We will tsrfc, the same shortcut we used before, to make the component like this. And now we have our daily forecast card. Let's go in here, take what we already have for this card like this. Let's cut it, paste it into this component. Make sure to import card. Go ahead and save it. And instead of rendering out that, we will render out this component we just made in app, daily forecast, just like this. So we just componentize the card. We'll do the same for the other two, but for right now, let's stay focused on daily forecast. However, having this in a separate component only introduces one problem. In this component, I have zero context to any of the weather information that I'm fetching in the app component up here in the use query. So I'm trying to access this data right here, but I haven't fetched data in this component, so I have no idea what data even is. To fix this, I'm going to do something that might seem a little bit strange at first. I'm going to take this entire use query that we already have in app, and I'm going to copy and paste it verbatim into this component right here, making sure to import use query and also to import get weather. And now if we save it, it should at least fix the error, so now we can see our page again. The reason I took the same exact use query and just copy and pasted it into this component is that as long as these two use queries have the exact same query key, which they both do, they're both weather, then it should only query once because these app and daily forecast components will mount at the exact same time. Even though it's two separate use query calls, it's smart enough to still only fetch the data once. Here in a little bit, we'll be refactoring it and taking this use query out of the app completely, but still, it's not a problem for right now. Like I said, we're not going to be double querying because we have the exact same query key in both of them. And actually, instead of using use query, I'm actually going to change this to a use suspense query instead. Later on in this video, we're going to add skeleton loaders, so I want suspense boundaries around each one. You'll see what I mean later by this, but in order to do that, we'll need to have this be a use suspense query rather than a regular use query. More on this later. Alright, now let's put our creative caps on for a second. From a very rough standpoint, what do we want this card to look like? Keep in mind before you roast me, I'm not a graphic designer, so this drawing is not going to be super pretty. What I was thinking is we would have our card here in this rough little box like this, and Open Weather in its doc says that the daily forecast is an 8-day forecast. So in my mind, this card would be broken out into rows like this, one row for each day. For each row, we'd have a couple of things from left to right. The first thing we'd have on the very left side for each row is the day of the week, like this. So Monday, Tuesday, Wednesday, whatever. Then next to it, we could have an icon, like for whatever the weather's going to be for the day, whether that's sunny, cloudy, rainy, whatever. Here, I'll draw a little sun in here. It's not super amazing, but you get the idea. And then we would have 3 more numbers for the rest of the row. We would have the average temp, so for example, like 73 degrees. We would have the min temp, so something like 61. And then the max temp, so something like, I don't know, 77. And each row would roughly, for the most part, look like this. So we have the day of the week, followed by an icon, followed by the average, then the min, then the max. And this would be 8 times because there are 8 items in our daily forecast. Again, show me a bit of mercy. I'm not a graphic designer, so I know this, doesn't look fantastic, but I think you kind of get the idea. So let's take that very rough draft design and translate it into JSX using Tailwind. So the first thing I'll do is just wipe out our data here entirely. We don't care about it for right now because we're going to format it. Let's make a div inside of here first. And let's give this div a class name of flex, flex call, and gap4. That will create each of our individual rows. Now inside of here is where we want to map over each row. So we create a new item in the flex box for each day. So basically for each day, we want to render something out. The way we normally do that, if we have an array, for example, when we hover over data, we want to look at daily information. You can see daily right here is going to be an array of objects. So what we can do is we can say data.daily.map just like this. And then for each day, we're going to map something. For right now, we'll say each day is just mapping over a div. Just so we don't forget, let's throw a key on this div. And something that will be unique with each day is actually the timestamp, which is just this dt. We can say that the key is just day.dt, just like this. Now the question is, how do we want to style each row? Because this div right here is representing each row for each day that we have. Well, we want to space everything out evenly. So let's give it a class name of flex, justify between. That'll make it in a flex row layout and space everything out evenly. Now, what do we want to have inside each row? If we look back at our design, remember that we wanted 5 things. First, we want the day, then the icon, and then the 3 numbers, the average, the min, and the max. So let's make an element for each one of these 5 inside this div right here. For the first one, the day of the week, let's just make it a p tag for right now, and we're just going to say date. For the icon, let's make an image tag, just like this, and let's give it a source. Now, how we can find the icon for each day is if we go to our weather schema here, and we look at our daily information, you can see that we have this weather array at the very bottom that has an object that has this icon on it. So this icon is what we can actually use to display an image. If we head back to the Open Weather API and we Control F on this page just for icon, and we go down a little bit, you can see we have this weather.icon field, which matches exactly what we're looking at in our schema. Right here, it says how to get icons. If we just click on it, it takes us to this page. And it tells us to get icons, we just need to use basically this URL right here. Here's a quick look at all the different icons we can get. So obviously this would be something like sunny or clear sky, daytime versus night. We have cloudy, we have rainy, stormy, snowing, you get the idea. So let's actually take this exact link that it gives us and go ahead and copy it. And if we go back to our code here, let's go to the source, make this a string with backtick quotes, and go ahead and paste it in. However, if we just keep it hard-coded to be this 10d at 2x, it's going to be this image right here, this 10d.png, so this little rainy icon, and that's not ideal. Obviously, it shouldn't be hard-coded. We want this to be dynamic. So let's actually replace this entire 10d at 2x with $ quotes to inject our own expression into here, and let's pass in the actual icon that we're getting from the response. Like I just showed you a second ago, if we look at the daily information and we look at weather, we have this array and then an object inside the array that has icon. So it's pretty deeply nested in here. Now, one thing I will point out is that weather, like I said, is an array because technically over the course of the day, there can be multiple weather conditions. We're not going to worry about this for right now. Let's just assume we'll take whatever the first weather condition is. In other words, index 0 in the array of weather. So what that means is that day that we have right here represents this z.object. So to access the icon, we need to do day dot weather at the 0 index dot icon. So let's do that. So for the source here, we will say day dot weather. And it's nice that we have this type with Zod because now we have IntelliSense. We'll say weather, take the 0 index, and we'll do .icon just like I said. And just to be safe, we'll give this an alt here that will just say weather icon. Go ahead and go back to our app and now save this. You can see we have date, 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 all this, and we actually have the weather icons already on this card. I want these icons to be just a little bit smaller, so I'm going to give it a class name for the image, and let's just say size 8. Go ahead and save it, and now they're a bit smaller, which makes our card not so huge. Now let's get the average temp, the min temp, and the max temp. If we look back at our schema here, and we look at this temp object, you can see we have day, min, and max. So we're going to use these 3 numbers right here. So let's actually make p tags for all 3 of these. So after the image here, let's make a p tag for right here. And the way we can access that is we can say day.temp.day for the average for the whole day. Day.temp.day, just like this. We'll go ahead and copy this, paste it twice. This will be day.temp.min, and this will be day.temp.max. Now if we go ahead and save it, for each day, we have the average for the day, the min, and the max in that exact order. I think it might look better if the min and max fields are slightly less visible and pop out less than the actual average for the day, because the average for the day is what's more important. So for the min and max, let's actually give these a class name. And for each of them, let's just say text gray 500/75 to make it slightly transparent. And we'll give this actually to both of them. Go ahead and save it. And that just grays them out a little bit. With this pretty simple component that we just made in this daily forecast, our daily weather information is now actually looking pretty nice and presentable. With the obvious problem right now being that we're just putting this date string here instead of the actual day of the week. So let's address that. So let's replace this date here with a JavaScript expression. And again, inside of here, if we hover day, the actual date will be given to us by this DT. Now DT is going to be in Unix time, which is why it's a number and not a date object. So what we can do to actually make this a date is inside this expression, we can say new date, just like this. And inside of here, we want to pass in day.dt times 1000. And that's because this date constructor that we're using in JavaScript expects dates to be in milliseconds, not seconds. But the DT that we get from OpenWeather is in seconds. Once we've done this, we can say to locale date string, just like this. If we go ahead and save this now, this will convert each one to a date string. So we can see right now, 1023, 1024, 1025, you get the picture. Each row has its own respective day now. However, I don't want this to be day of the month. I'd prefer for it to be the actual day of the week, so like Monday, Tuesday, Wednesday. So how can we get that? Well, all we have to do is change the arguments here that we have in this toLocalDateString function. We can pass in undefined for this first argument because we don't want to pass in any local time zone information. But for the second argument, we'll make it an object. And one of the first things we'll do is just give it weekday short, just like this. For date strings, this second argument that we're making this object right here has a couple of different customization options. One of them is weekday, which can either be long or short. Long means something like Monday, Tuesday, Wednesday, and short is just the abbreviation, so MON, TUE, and so forth. So if I save it now, instead of having the day of the month, we just have the day of the week, but abbreviated. The day I'm filming this on is Wednesday, so it makes sense the first day in the forecast would be Thursday because that's tomorrow. And again, we have 8 days, so it's Thursday going all the way to the next Thursday. Let's now clean this component up just a little bit more. First things first, I don't really want fractional temperatures, so I don't want 96.24. I'd rather just have it say 96. To do that, what we can do is for each of these temperatures, we can just wrap each of them in math.round, just like this. Go ahead and copy this for each one. Wrap them all. And now if we save it, we have integers for temperatures and no more decimals. I also want to put the units for each one. And I actually just learned that if you're on Windows, something cool that you can do is you can actually do Alt and then 0176 on your numpad to actually do the degree symbol. So that's pretty cool. And then I'm using Fahrenheit, so we'll do degrees Fahrenheit. We'll take this and we'll add this to the other temperatures as well. That way for each one, we are saying degrees Fahrenheit. Now, if we look at our rows, you can see that not everything is aligned perfectly. For example, the start of this 98 degrees Fahrenheit is not left aligned with this 91 degrees Fahrenheit. They're a little bit off. You can see that even more so with this 94 right here. It's jutting out to the right when compared to 91 and 96. This most likely stems from the fact that our weekday names on the left side are not all the same length. For example, Wednesday, or WED, is longer in width than Tuesday is. So we create this weird kind of offset look. One quick workaround to this is that all the entries in the left column here, like Thursday, Friday, Saturday, are all a fixed width. So to fix that, let's go to our p tag for our day of the week, throw a class name on it, and give it width 9. Now, if we save it, everything should now be aligned because we're ensuring that each of these has a fixed width, so the other ones are starting all at the same point. Nice, so everything is aligned great now. And that's actually going to be it for our daily weather card. Just to do a quick recap so we're all on the same page and understand what's going on. In this daily weather card, we're first just inheriting from the shared card component that we're going to use for all of our cards. Again, this is pretty basic, just has a title plus children and some stuff like roundedness and padding. But the daily forecast card specifically just has one div that is flex call, so we map out each one of our rows like this in a flex column layout. To get each day, all we have to do is data.daily.map. That actually gives us each day, and then for each day we can just map out the information. Flex justify between is to make each row in an actual row layout, making sure that everything is spaced evenly apart. And then we just have elements for each of our items, like the day of the week, the icon, and then our 3 temperatures, the average, min, and the max. However, one thing I'm actually seeing real quick that can be a super fast optimization thing is getting rid of this div right here because it's a little bit redundant. I'm a pretty big hater of having divs that are unnecessary because I think it makes the code a bit harder to decipher and fix later on. When I say this div is redundant, I mean that if we look at our card component here, we already have this div right here that is wrapping the children. And then when we inherit it like this, we're wrapping another div around children as well. So it's like we're essentially double wrapping it, which doesn't really cause problems, but also it's not the best way of doing it. The easiest way to fix this and a way that I like to handle this is go into our card component here, and let's give it another prop here. It'll be an optional prop though. We are going to call children class name, just like this, capitalize the N, and it'll be an optional string. We'll also destructure it out of here. And then on this div, let's give it a class name. And this class name is going to be, you guessed it, children class name. Now, if we go ahead and save this file, instead of having this redundant div, we can actually take the style exactly, which is just this flex call gap 4. Let's paste it up here so we don't lose it. And we can actually wipe this div out completely. And instead, we can give it another prop, the children class name, where we just paste this in. Now, if we save it, it'll behave the exact same. We did just add a prop to the card component, but we completely removed a redundant div, which in my opinion makes it easier to read in the future. Now that we have the daily forecast done, let's move on to the hourly forecast. Like the daily forecast, let's go over to our file explorer, and inside cars, we'll make a new file, call it hourlyforecast.tsx. We'll do tsrfc to create the component, and just like daily, we'll make this be a card that inherits from our shared card component. If we go back to the drawing board, here's what I was thinking for our hourly card. We'll have a card that is quite a bit longer than it is tall, just because for hourly, we're going to have 48 hours, so there's going to be a lot of stuff, so it's going to have to be able to scroll side to side. I was thinking for each hour, we could have something like the actual hour number, so like, I don't know, might not do military time, but let's say we do military time. We'll have the number. We'll have the icon for what it's going to be during the hour, so whether that's, sunny, cloudy, whatever. And at the bottom, we'll just put the actual temperature we expect it to be. So for example, 74 degrees Fahrenheit. And this will be for every single hour. So basically it's the opposite of what we're doing for daily weather. Instead of having a bunch of rows that kind of go in a vertical format, we're going to have a bunch of different columns that go in a horizontal format. So we'll have hour 1 right here, hour 2 right here, 3, 4, and you get the picture, and it's going to scroll side to side. That should be, honestly, super easy to do, so let's go ahead and get started. We will do the exact same thing we did for daily forecast by taking the same query from app. So let's take this exact same suspense query from daily forecast, and let's copy and paste it in here, making sure to import the suspense query and importing our API function. Again, I want to emphasize that because all of these components are mounting at the same time and share the same query key, we're not actually going to make multiple network requests. It's only going to make one, even though we have multiple use queries. I mentioned just a second ago that we want this hourly card to be in a horizontal format, meaning we want it to be in a flex row layout. So to do that, we can kind of copy this similar thing we did for our daily forecast with the children class name, but instead of doing flex call, we'll just do flex row. If we go back here, let's give it a children class name, and we will just say flex, and let's do gap 6. I could add flex row here, but flex row is the default, so technically it's the same as just not having it at all. inside this card now, just like we mapped over the daily data using this data.daily.map. Let's do the exact same for the hourly. Again, if we look at data, you can see it's an object. We have this hourly, that's an array, kind of in the same vein as daily. So what we can do is we can say in our card here, we're going to do data.hourly.map, and then for each hour, we're going to map out a div here. Card is going to complain because we're missing the title prop, so let's actually go to app, take the title that we already had for the hourly forecast, take this, and we will just put it back into here, so now we can make card happy again. Now let's ask ourselves, for each hour that we're mapping over, what do we want to display? Well, in the little rough draft design that I just drew out, each hour just had the time, the icon, and then the actual temperature all stacked on top of each other, so in a vertical layout. To get this vertical layout, we can give this div a class name. Let's give it flex call, and we'll give it a gap of 2. The gap isn't going to be huge, just enough to create separation. But this should at least set up a reasonable column layout for each individual hour. Just like the daily forecast, we'll first display the date, except instead of being an actual date like Monday, Tuesday, Wednesday, it will be the time of day. It only makes sense if we're doing hourly forecast to have this be the actual hour in question. So we'll make this a p tag right here, and similar to daily, we will make this new date, calling the date constructor, and just like day, the hour also has a dt, so we can say hour.dt times 1000 to get the actual date. And then to get the time, all that we have to do is call toLocal time string, just like this. Before we go any farther, just so you can see how this looks, let's actually save this file real quick. And in our app, instead of rendering out this card, just like we're rendering out daily forecast, we're also going to render out hourly forecast. And now if we look at it, we can see right here on this hourly forecast card, we have a bunch of times. We have 8 p.m., 9 p.m., 10 p.m., and you get the idea. Back to our hourly forecast component. Right underneath this timer here, we want to have an icon for the weather, just like we have for daily. So if we go to daily, you can see we have this image right here. And I think because we're going to reuse this, it might be a good idea to actually make this its own component. So to do that, it'll be super easy. Let's just take this image tag. I'm going to copy it exactly. Go into our file explorer, and in the components folder, let's make a new file just called weathericon.tsx. tsrfc again to make this component. And then in here, let's just return what I just copied, the image element. And now what we can actually do is instead of hard coding this day.weather.icon that we're doing, we can just pass in source, which we will just make a prop to this component. So we'll say source, and source is going to be a string. So essentially now we have a shareable component that we can use between both our hourly forecast and our daily forecast. We can implement it in both. If we go to daily forecast, let's get that real quick. We'll just take this source right here, which is the day.weather0 icon. Let's copy this. Let's actually get rid of this whole thing and just render out weather icon in its place, giving it a source of this right here. Now if we save it, it should behave in the exact same way, with just being a reusable component. So now that we have it in the daily forecast, let's copy it and let's paste it verbatim inside of the hourly forecast right here, right underneath our date. Go ahead and import it. And the only major difference is that instead of being date.weather.icon, it'll actually be hour, because the format is going to be similar. We have this hour object. Inside of that, we have this weather array. We're going to take the first index of it and then grab icon. So now if we save it, boom, now each of our hours in our forecast has its own icon. And that, my friends, is how you speedrun shared components in React. Anyways, let's get back to the hourly forecast. The last thing we're missing in here is our actual temperature, which should just go right underneath the weather icon. So let's make another p tag right here. And for the temperature, all we have to do for each hour, we can access it with this temp right here. So it's super simple. All you have to do is say hour.temp. However, just like the daily information, I want to have a unit on it, so I'll take this degrees Fahrenheit right here, add it to the end, and I also want this to be rounded, so I'll do math.round, just to make sure it's an integer and not a decimal. Now if I go ahead and save it, we also have the temperature for each item. The next obvious problem you might notice is that now our page has a huge scroll bar because, shocker, our content is just way overflowing all this. We don't actually have a proper scrolling container set up, so all the hours are literally just overflowing the side. Clearly this is not something that we want. A super easy fix for that is on this children class name here. All we have to add is overflow x scroll, just like this. Now if we save it, this is going to scroll within the container. So now the actual container itself is scrolling. The page itself will still actually scroll because this top card is still messing us up. However, this component itself, the hourly forecast, is no longer causing the entire window to scroll. It's going to be a super long list because, like I said, there's 48 hours of forecast, which means there's 48 of these objects. So yeah, we got a lot of horizontal space here. Let's quickly improve some of the styling to make it look a little bit sharper. First of all, I don't love that the time right here is overflowing or wrapping down. I wouldn't want the 8 o'clock to be on a different line than the PM. Doesn't really look very good. So what we can do is go to the P tag where we're doing our time. Let's put a class name on here. And all we have to do is give it a white space, no wrap, just like this. And now it's not going to wrap anymore. For each hour, I want all the items to be centered, not left aligned. As you can see here, obviously this weather icon is not centered directly under the time. So that's something we can super quickly fix if we just go onto this outer div right here, flex call, and we give it item center. That'll make sure everything is centered within the column. And each of the hours feels a little bit cramped right now, so I'm actually going to add P2 to create a little bit more spacing for each hour. And this is already looking quite a bit better. The very last thing is I honestly don't like this time format right here. I think having the 80000 just seems super redundant. These are just extra zeros right here. We don't need them. So to format our time, we could do something pretty similar to how we handled the dates on daily forecast. Inside of our toLocal time string, we'll again make the first argument undefined so that this stays relative to your local time zone. And for the second argument, we'll again pass in an object. And for this one, all we have to do for the options is give it our numeric, just like this. We'll also give it minute 2-digit, and then we'll give our 12 true. If we save our file now we can see our times are just formatted like this without the 2 extra zeros. And that, ladies and gentlemen, is our hourly forecast card done. There's a chance we could come back to it later to make some improvements or changes, but with what we have right now, this is working great. We can see the forecast for all the next hours. So we have 8 p.m., 9 p.m., 10 p.m., and I can scroll if I'm curious about any hour in the next 48 hours. Super crisp, super smooth. Now on our page, or other words in the app component, we're displaying both the hourly forecast and the daily forecast in the exact way that we want it to. Theoretically, given any latitude and longitude coordinates, I can now see the hourly forecast for that exact area and what the next 8 days are going to look like. So we've already made tons and tons of progress from where we started. But let's keep going. The last big chunk for this dashboard is getting the current weather information. We already have hourly and data, so let's get the current weather component set up. Just like the other two, same process we're getting familiar with. If we go to our cards, we'll make a new file. Let's call this one currentweather.tsx, tsrfc to generate the component, and same pattern as before, we're going to take the exact same suspense query and add it to current weather. I know I keep saying this and reiterating it, don't mean to beat a dead horse, but as long as they have the same query key, it's not going to be making multiple network requests. They're going to share the exact same query. Let's go ahead and just save this component now, and let's render out current weather. And here, we finally have individual card components for all three. And just to make sure actually we have the same title, let's not forget this real quick. Let's do title. And for here, make sure before we forget to render out the card, the same shared card you've been using this whole time. And we will pass in this title. Oops. Pass in this title right here, just like this. Now if we go ahead and save it, go back here, and we can just make this current weather, and now it's happy, and we have it on our page. The main question is now, what do we want this current weather card to actually look like? Let's once again go back to the drawing board. For this current weather card, here's kind of what I was thinking. This card, unlike the hourly forecast, but similar to the daily forecast, is probably going to be a bit taller than it is wide. What we could do for this card is right at the top center of the card, have the temperature in big, bold letters. So for example, something like this, right in the middle, just so it's very obvious and sticks out to the user. Immediately under that, we could put the current weather condition, so something like, I don't know, this can say cloudy, and then we'll have the icon that corresponds to that exact condition, either to the side of it or directly under it. So for cloudy, it'll be some cloud like this and an icon. And then right under this, to fill up more space, we'll probably put what the time it is at the actual location that we're looking at. Again, with their app, we're going to be able to see the weather for anywhere in the entire world. So it's probably nice to know what the actual local time is there. So let's say, I don't know, it's 14:52 o'clock. That can be a time under it. And it won't be quite as big as the temperature. This should be a little bit smaller. So this is not quite to scale. And then at the bottom, maybe we just have a few stats kind of in a row. So we could say like right here, maybe what the temperature feels like. We could say, maybe humidity is in this box. And then we could say, I don't know, something like wind speed or wind degrees or something like that. And this could be just a very rough outline. So we'll have all this in a flex call starting from the top because it's all kind of in a vertical layout. Since we want all this to be in that vertical layout, let's go into our code here. Make sure we have our card. It's annoying sometimes how Prettier formats these. And we'll give it a children class name of flex call, again, just to make it all vertical. I also want to make sure that all this stuff is centered. So I'm going to give it item center, just like this. Now that we have this, let's get the rest out of the way. For the first section, like I just mentioned, we'll have the temperature in big bold letters. So let's replace this current weather right here with an H2, not H1 because I'm going to reserve that for bigger headers later down the road. And here we need the current temperature. So how do we get that? Well, if we look at data, we can see in the current object here, we have this temp number. That is the current temperature. So to get it, all we have to do is say data.current.temp, just like that. Same as all the other ones, I also want to use degrees Fahrenheit. So we'll take this exact same unit, and just to keep things consistent, we'll also do math.round, just like this. So now if we save it, we'll have the current temperature of wherever we are. Right now it says 74 degrees. So wherever in the world is 10 latitude, 25 longitude, it's apparently 74 degrees Fahrenheit. This temperature right now looks way too tiny and out of place. So on this H2, let's give it a class name. Let's give it some pretty fat text. We'll say text 6XL because we want it to be quite big. And I'll also give it font semi-bold just to make it pop out a little more. And text center just to make sure it's centered. So now that looks quite a bit better, way easier to see. Next up, let's get the weather description and the weather icon. I'm going to want the big bold temperature and the weather icon and description all in the same div just for organization purposes. So let's actually wrap this H2 here, wrap it in a div. And for this div, just to create some separation between them, let's make sure this is all vertical. So we'll say flex call, and we'll also give it gap 2 for just a little bit of separation. So if we go ahead and save it, it now has its own div that we can also put the icon and the description inside of. We already made a share component for the weather icon, which again is called weather icon. So let's take this, copy it, and just paste it right here, making sure to import it. And then for the actual icon, if we go into data, look at the current information, it's pretty much the exact same thing as the other two. We have this weather weather array of objects. We'll just take the first index, the icon. So instead of doing day.weather, all we have to do is data.current.weather, just like this, and now we're good to go. If I go ahead and save it, boom, now we have a weather icon. I want this weather icon to be centered, so I'm going to actually add item center on this div right here, and that'll make sure it's centered directly below the temperature. However, right now this icon honestly looks really tiny compared to the actual temperature with how big the text is. So let's make it a bit bigger. One problem we're going to run into with that though is if we try to modify the size of the weather icon directly, we're going to modify it every single place that it's used. And I don't want to change the size of how it is in the hourly and daily forecast. So what I can easily do to make this more customizable is add a class name prop that can be optional. That will just be a string. And we'll also pull class name out of the props here, meaning destructure them, that we can use to pass in our own custom styles. The way I typically handle custom class names like this is with a tiny package called CLSX, which is a super tiny utility function that just resolves conditional class names like this, instead of having to do some ugly string interpolation. Because let's be honest, string interpolation looks super scuffed. To get CLSX, all you have to do is go into your terminal, make sure you have a new one open, and just run npm I CLSX just like this, and it'll get it added to your project. Again, it's a super tiny utility. It's not a big package we're installing. Once you've done that, literally all you have to do is just make your class name an expression like this, and you're going to wrap it in CLSX as if you're calling it like a function. You just want to make sure you import it from CLSX. Now what we can do, in addition to having size 8, which will be our default style, is any custom class name we pass in, we can just put on top of it. And this CLSX function will actually resolve this. So if we pass in a class name, it'll just get appended to the same class name. And if we try to override the size, it will override it. Meaning it's size 8 by default, but if I want to pass in something bigger or smaller, I can. So now if I go ahead and save this file, and I go back to current weather, I can give this weather icon our own custom class name. And instead of defaulting to size 8, let's actually say, I don't know, size 14. Go ahead and save it. And now our icon is quite a bit bigger without impacting the size of the icon on hourly forecast and daily forecast. So that's a quick sneak peek into how I handle conditional styles, or when I need to do my own custom class names, where it's maybe the same in a lot of spots, but has slight variations in other spots. Now if we go back to our current weather component, right underneath the icon, I want to put the actual weather condition that we're in, like cloudy, sunny, rainy, you get the picture. To do that, all we need to do is add, we'll do an H3 for this one because it should be slightly smaller than the temperature. And to get the description for the current weather, it's actually pretty similar to how we get the icon. We hover over data, look at current, and you go to weather. You can see we have this description right here. What we can do, we can actually, let's just take this exact thing right here, and we'll say data.current.weather at index 0.description, just like this. Now if we save it, we have the weather description. This one in particular says scattered clouds. Let's make this look a little bit nicer by adding a class name here. Let's add capitalized so it capitalizes the first letter of each word. Then we'll also make it text XL. So it's still relatively big, but not nearly as big as the actual temperature. Save it, and I think that looks quite a bit better. Underneath the temperature, the icon, and the actual weather description, let's get the time figured out. When I say I want to put a time on this card, I think it would be good to put the actual local time of wherever we are, because to me that would make sense in the context of the current weather information. So if I want to look at somewhere in Germany, the time it gives me for this card would be German time zone, not an American time zone like my own. I like to have it so that we have in big letters saying local time, and then right underneath it have the actual time itself. So to do that, we can actually go under this main div we have right now, and let's actually make another div, just like this, and we will give it a class name of flex call, and gap2 to create this sort of layout. We'll make the first thing in here a p tag, and this is just going to say local time. Right underneath it, let's make another header. So it's going to be similar size to our description, so we'll say h3, and this is going to have the local time. There's a couple of different ways that we could do this. However, the way I'm going to do it using the time zone that is actually returned from data. So if we hover over data, you can see we have this time zone string right here. This is actually very useful if we want to get the local time. A way we can do that is by inside of here, making a JavaScript expression, and we can say new int L, just like this, dot date time format. For the first argument, we're going to pass in a string that is en-us, since this is my preferred format. And then for the second argument here, just like all the other dates that we've worked with, we'll make an object that we can customize. In here, we'll say hour is going to be 2-digit. We'll also say that minute is the same thing. We also want it to be 2-digit. And just like hourly, we'll make hour 12 true. And then to get the actual local time zone of wherever we are and not my time zone, what we can do is give it a final option that is just time zone, just like this. And that will just be data.timezone. Because again, we hover data, we have the time zone right here. So we pass that in as another option to our date. And this will actually create our date for us, completely using the local time of whatever the time zone is that comes back from our call. You'll notice this whole thing right now is going to be highlighted red because the date itself can't be a React node. We need it to be a string. So to actually format it as a string, what we can do is after this big chunk right here, we can just say .format, and inside here, you can say new date, and you want to pass in the actual time of the date. So we'll say for the time, it is stored in data.current.dt. That is the current time. So we'll do that. Data.current.dt times 1000, like always. And now, if we go ahead and save it, you can see the local time of the coordinates 1025, or whatever we have in our query right here, is 4:26 a.m. It looks a little bad right now like this, like a bunch of just kind of jumbled text. So let's style it up. We go down here. For our local time, for this p tag, let's go ahead and give it a class name. We'll say text XL. And then for the actual time itself in this H3, we'll also give it a class name. And we will say text 4XL and also give it font semi-bold just so it sticks out quite a bit. Now if we go ahead and save it, the text is quite a bit more readable. However, now this time just got way bigger. This local time is off center. It looks kind of weird. So all we have to do is just add text center to this, just like this. And now it's back to looking good. The only last thing now to do on this current weather card would be to add the 3 quick sections at the very bottom, getting the feels like temperature, the humidity, and the wind speed. These will all share the same style, so this will be super simple. We'll go down here below this div and make yet another div. we will give it a class name of flex justify between so that each of these three little sections spaces evenly from each other. And then for each little section, we'll have another div. For each of these, we'll give it a class name of flex call gap2. All we're going to do for each one of these divs is just give it a p tag that will say, for example, for the feels like temperature, we'll just say feels like. And then for what it actually feels like, meaning the temperature, all we have to do is data.current. Oops, crap as an expression here. Data.current. You can see we have feels like right here, so we can just use that. We'll want to keep the same consistency with the units, so we'll do degrees Fahrenheit. And we will also math.round this whole thing. Now, if we do this for our first thing, we'll see feels like 72 degrees. Clearly, it doesn't look very good yet, especially because there's only one element. So let's make some styling to fix this. In this flex call div right here, let's make sure we also throw item center to make sure they are vertically aligned with each other. So it does not look very good because there's only still one item there. So let's actually take this div chunk here. I'm going to copy it and we're going to paste it twice, because each section is going to look very similar to each other. The second one, instead of saying feels like, is going to just be humidity. And instead of doing the data.current.feels like, what we can do instead is just replace this with data.current.humidity. This is not going to be degrees Fahrenheit. This is going to be a percentage. So we'll use the percent symbol. And then for this one, this also is not going to be feels like. This is going to be the wind speed, which we will just call wind. And then we can replace this whole thing with just data.current.wind speed, just like this. Wind speed in imperial units is going to be miles per hour, so we will just say mph. Now if we go ahead and save it, we have three different things: the feels like temperature, the humidity, and the wind speed. Obviously still looks pretty horrible, but at least we have all of our data here. To fix this weird styling, let's make sure that this flex justify between div right here is width full to make sure it takes up the entire space of the card. We save this now, it spaces it out, so it takes up the whole card. Next, I want these numbers in the bottom section, like the feels like number, the humidity percentage, and whatnot, to stand out against their labels. So on each label, to make it slightly darker and less in your face, I'm going to throw a class name on it, and I'm just going to give it text gray 500, just like this. And we'll actually copy and paste this class name on the other labels as well. Go ahead and save it, and now they don't stand out against the numbers so much. Makes the numbers pop a little bit more. And lastly, it's pretty clear that each of these items, so like this whole item at the bottom, next to this time, next to the stuff right here, is not separated out with any space at all. So all is kind of just cluttered. So if we go back up here to our card, where we have the children class name, let's actually throw a gap on here. Let's just give it, I don't know, gap 4 for right now, just to make everything a bit more spaced out and a little bit nicer. Actually, maybe let's do gap 6. Honestly, now our card is looking pretty good. It doesn't look perfect yet, so we may also revisit this in a bit with the rest of our cards. It looks a little bit awkward right now because these cards are so wide, but for the actual finished dashboard, these cards aren't going to be taking up the whole width of the page, so it's not going to look so stretched out. It'll look quite a bit better. So for now, let's move on. The only last card that I want to make for this dashboard that's going to be consuming information from the API is just a card that displays some of the extra information that we're getting back that we're not currently using. If we go to the weather schema and we look at it, we obviously have the daily and the current and the hourly. However, there's a lot of things here that we're not actually going to be using. So for example, we have like the sunrise and sunset time. We have, I don't know, the clouds. We have the wind degrees. Basically just a bunch of fields that aren't being used at all. We've got plenty of real estate to work with on this dashboard. So let's actually use these other pieces of information on a final card that we'll just call additional info. So going back to our cards folder, we'll make a final component in here that we're just going to call additional info.tsx, tsrfc to make the component, and we'll go ahead and save this file, close this, and just like the other ones, we'll make it inherit from the same card. And for this title, we're going to give it a title of additional weather info, just like this. This card is just going to have some additional weather information, so it's not going to be anything crazy. We're not going to go really weird with the styles. We'll keep it pretty basic. So let's actually wrap this back in parentheses here, fix this annoying formatting that Prettier always does. And then in here, what do we want to do? Well, in terms of design, I was thinking about just making it something super simple. We'll just have all of our additional fields laid out into columns. So we'll have the card like this, and we'll have some columns that are just going vertical like this. For each individual column, what we can do is we can just have the label. So I don't know, like, wind speed here on the left, wind speed, and then on the right would be the actual number. So this is not anything crazy, just super simple. For like cloudiness, we could do cloudiness, whatever, and then have some number here. And we would do that for each of the different pieces of information that we have. Super, super basic layout. So to create this vertical layout here, let's give our card some children class name. And we're just going to say flex call. Let's make the gap a little bit bigger this time. We'll say gap 8. Now the question is, how do we actually want to render out the information inside of our component right here? I could write each field individually since they're all going to be a bit different, but then I'd have to spam a bunch of the same JSX and this component would look a little bit messy. I prefer being able to map over something, that way we only have to write the core JSX in one spot. What I mean by that is at the bottom of this file, I'll make a new variable. I'm just going to say const rows, and it'll be an array. And in here, for each of these rows, I think we should make an object with 2 properties. We'll have label, and then we will also have value. Label will be what the user actually sees, and value will be what it's actually called from the API. So, for example, let me show you what I'm talking about. If we take the same exact suspense query, let's go ahead and get it into this card as well, making sure to import our stuff. And if we now hover data, we can see that current has something, for example, like clouds. In this case, the label will say something like cloudiness, and value would be clouds, so it maps it as property. So what I can say for this is for label, I will say cloudiness, and we'll do percentage just so we know the unit, and then the actual value itself is just going to be clouds. We just want to make sure this value matches exactly how it's going to look like in the response. And we basically just want to do this for all of our fields. But let's pick out a few important fields that we want aside from cloudiness. If we look at data here, we can see that in addition to clouds, we have UVI. So I think we can include UVI. Let's take the wind degrees because that'll be the wind direction. We'll also take, let's take pressure up here. And then we'll also get sunrise and sunset. So that would make 6 total properties that we're getting, which I think should be plenty. I'm lazy and don't feel like writing these out individually, so I'll ask ChatGPT to do it for me. And here is what it cooked up. So for each of these, we'd have the same thing, where we just have the label, which is what the user sees, and then what it actually is on the endpoint. So this should be good. I pretty much just gave it the response structure and asked it to just take those 6 fields into account, and now we have a label and value for each thing. Now that we have this rows array, what we can do is we can go back to our car component here. We can make an expression, and we can say rows.map. And then for each row, we want to, for each row, like everything else, just map out a div here. For each row, what do we want it to look like? Well, I mentioned we wanted to have it be flex, justify between. So let's go ahead and do that. And all it's going to be is something super basic. We'll have 2 spans inside of here. Span 1 is just going to be the actual label that the user sees. So row.label. And then the second span that we have is going to be the actual value from the endpoint. If we make sure that our values match up 1-to-1 with how we have them declared in our schema, and we look at it, I can just access data.current.clouds, for example, to get that particular number. So the way that we can do this in our map, we can say data.current@value. And it's really that simple. Actually, it's not that simple. It needs to be row.value, not just value. However, we're going to get a TypeScript error here saying that it has any type, and it's going to complain with the prolong thing that is basically just caused by the fact that this array is not declared as const. So if we just say as const, it'll actually just get rid of that error completely. We're just telling TypeScript that this array is never going to have anything pushed or popped from it. It'll always be this, so it can safely assume the type is never going to be anything different. And just to clean things up a little bit, I like to destructure things wherever I can. So instead of doing row just like this, let's actually destructure both label and value out of here. And instead of doing row.label and row.value, we can just use them directly after destructuring. And then before we forget, like all mapping, we need to make sure we throw a key on this. So let's throw a key, and we'll say our key is just equal to, I don't know, the value, because that's always going to be unique. So let's go ahead and save it. And now let's actually render out this card on our dashboard so we can actually see what we're working with. So let's go back to our app here. And right under daily forecast, let's render out additional info just like this. Now if we save it, scroll down, we have this additional weather info card, which is the component that we just made. So this is nothing crazy. It's actually a pretty basic component. Let's style it up just a little bit. For the label, let's give the label a class name, and I'm just going to give it a class name of textgray500 just to make it a little bit less obvious than the value itself. We'll also want to convert this sunrise and sunset numbers you see down here into actual dates. Having them as Unix time doesn't really do anything for us. So basically, we need to format these as actual dates and the other ones as numbers. So that's going to be a little bit of an issue with the way that we currently have it. What I like to do when it comes to something like this is I make a separate component that just formats the values instead of doing a nasty ternary or conditional inside of this expression. Right below this component, I'll actually just make a super simple new one. We'll say function format component, just like this. This is going to be another React component. To format each thing properly, we'll need to know the value and the actual number that we have for that value. So we'll make two props. We'll say value and number. And to make TypeScript happy, we'll say value is going to be a string. And then number is obviously just going to be a number. For most of these fields, we just want the raw number. So by default, we can just say return number like this. However, above this return, specifically if it's a date, we want to do something different. So what we can do is we can say if the value is equal to sunrise or the value is equal to sunset, then we want to return a formatted date. So we'll say return new date. And we will do number times 1000. Again, just converting the actual date time to a real date object. And then just like before, we will call to local time string. We go ahead and save it, just get a little bit of formatting here, makes it a bit nicer to read. We'll do the same thing as before, undefined for the initial options, pass in the customization for the second argument here. Oops. Sometimes this formatting gets a little bit funky. I want to map exactly what we have for our hourly forecast, so it's the exact same. So if we go in here, see what the options are for this. Let's actually just take everything we have inside of here, copy it, and we will actually just put it exactly verbatim inside of here. Now if we go ahead and save this component should be good to go. If I was using this customization options right here in a bunch of different spots, I'd probably extract it out into its own utility. But because we're only using it in two spots, I don't really think it's that big of a deal to just copy and paste it. Again, essentially all this component is doing is normally we're just going to return the number to format that number directly. However, if it's a date, meaning if it's sunrise or sunset, then we're going to actually format it as a date. So now what we can do is we can go up here, and inside of this span right here, we can actually just completely replace this by rendering out format component just like this. For our props, we obviously need value and number. For value, it's going to be just a direct one-to-one. It's going to be the actual value. And then number is going to be what we had before, which was data.current at value, just like this. That's the actual corresponding number from the endpoint. Now, if we save it, boom, we have the rest of them formatted as numbers, but the sunrise and sunset are now formatted as dates, just the way that we wanted it. Before we call this card good, there's one more thing that I want to add to it. All of our other cards have some sort of icons in some capacity, like the weather icons. It makes them look a lot less bland and a bit more, I don't know, sophisticated or styled. But this card right here is just displaying text, so it looks a little bit boring, at least when compared to the other cards. What we can do is we can actually add some quick SVGs to make these look a little bit cooler. If I head over to svgrepo.com, I can see all sorts of SVGs that I can just get completely for free. For example, for cloudiness, I can search, cloud in here, and I can take any one of these icons and use them as a cloud SVG in my app. So real quick, off screen to not waste your time, I'm going to find an SVG for each one of our 6 categories and get them added to our repo. Alright, so I found an icon for each one of our things. We have this cloud for cloudiness, pressure for pressure, sunrise and sunset. We have UV, and then we have wind. These will be super easy to add to our project. So basically all that I'm wanting to do is in this additional info card, for each little field that we have, I'm wanting to have an icon next to the label. So for cloudiness, we'll have a little cloud. For UV index, we'll have a little UV symbol, and you get the idea. Just a little icon for each one to make it look a little cooler. How do we render out SVGs as React components? There's a couple of different ways we can do it, but by far the simplest way, and the way that I like the most with Vite, is using a super tiny package called SVGR. If you look up SVGR, you can find this page called Vite plugin SVGR. Let's get this added to our project real quick by taking this command right here. Go ahead and copy it, open up our terminal, paste it in, run it, and now we have SVGR and we're ready to use it in a super simple way. all we have to do is do exactly what it says right here. Basically, just add it to our plugins, like how we have React and Tailwind. So if we go to our vconfig here, we already have React and Tailwind. Let's now just add svgr like this. This will be imported from the plugin. Looks like TypeScript isn't recognizing it for the import, but it should be imported just like this. What this tiny little package allows us to do now is actually import SVGs as React components, like it says over here right in the docs. You basically just import it and you add $React, and it'll actually import it as a React component that is already ready to use. So what I mean by that is if we close out of these, go back to additional info, I can now import these SVGs as components by doing something like, for sunrise, for example, I can say import sunrise from, I'll say file path is /source/assets sunrise.svg, just like this, and then add $React, and this will make the sunrise actually a React component. And I can actually do this for all 6 of our icons. So I'll take this here, make it 6 times. We'll make this sunset. We'll make this cloud, UV, do lowercase v there. And then what were the other 2 that we had? We had, wind. And then we also have pressure, just like this. And then we'll change each of these. This one's going to be pressure SVG. This is wind SVG. UV, cloud, and then sunrise and sunset. Now we can use each of these. Let's plug each of these icons into our rows array. What we can do is, like how we have label and value for each one, is also add an icon field. And this will just be a component. So the icon for clouds is just going to be the cloud component. And then we'll take this, actually copy and paste it for each one, just as such. And then this will be UV. This will be wind, pressure, and then we have sunrise and sunset. So these right here are actually all React components. By default, TypeScript is actually not going to recognize these as React components because the way it's importing it is a little bit unconventional. So it actually gives us this super nice thing we can use right here, this line. If we just copy it, it says to add it to our venv.d.ts. So let's take this. Let's go to that exact file, which we don't actually have. So let's create it. We'll just make a new file in here. We'll say v-env.d.ts, just like this. And let's paste this line in here. And now we go back to additional info and we save it. It should resolve all of these correctly. Oh, and also this venv.ts file should, I don't think be at this level. I think it should actually be inside of source, which may be the issue. Remove that. Yeah, okay, if we remove that, it looks like it resolves those imports. So no more annoying TypeScript errors. Looks like, oops, we forgot the slash on this. So now it should import all of these icons correctly. Now that we have them in here, let's actually get them displaying on our card. We already have each of the icons in the rows now. So what we can do is we're mapping over our rows here. We can also destructure the icon out of here. And actually we'll make sure it's capital I because it is a React component. So we'll make sure icon here, select all of them, capital I for component, just so we have proper conventions here. And then we want to render out this as a component. So let's take our label span here. Let's wrap it in another div. So we'll wrap div here, create some more spacing, and we'll just give it a simple class name of flex gap4. And then right after our label, let's just render out icon as a component just like this. What's really cool about SVGR is that you can actually pass in custom class names to give your icon certain sizes. So we can say, let's give this one size, I don't know, let's do size 8 for now and see how that looks. We go ahead and save it. Now we scroll down and look at our card. We have SVG icons for each label. I definitely think that having these SVGs adds some more personality to this card. Only thing we need to fix real quick is that all of these are black against a dark background, so it looks kind of bad. So let's actually throw the invert class on this too, and that will make sure they appear white instead of black. And the very last thing I want to do for this card is really quickly just adjust this wind direction. This number right here doesn't really make a whole lot of sense. The other numbers kind of do because we have the units next to them, but having just a raw number for the wind direction doesn't really mean anything. Now, technically it's in degrees, but I think one cool way to show this would just be to show an arrow pointing which direction the wind is going. I found another SVG on SVG repo called up arrow that just looks like this that we can use to point the proper direction. The way we can super easily do that is just how we have the formatting for sunrise and sunset, we can do a similar thing for the wind degree. So instead of having this return as a raw number, you can say if the value is equal to wind degree, just like this, then what do we want to return? Well, all we want to return is just the up arrow SVG. So we can actually import that like our other components. We can say, take this line, we can call this the up arrow component, and it'll be from up arrow to SVG, just like this. And now for right here, all we want to do is if we're on wind degree, we want to return up arrow. And to get it pointing the proper direction, we just want to rotate it by whatever the wind direction is. An easy way that we can do that is to actually just give this up arrow a style tag, which again is a nice thing about SVGR. We can give custom class names, styles, everything like that. And inside of here, what we're going to do is just say transform, and you want to transform and a rotate. So we'll say this, we'll do the back to quotes here, we'll say rotate, and the amount of degrees we want to rotate it is going to be just whatever the number is. So we'll say $, curly brackets to inject something in here, say number, and you want it to be exactly that many degrees. Because the arrow is an up arrow, that means its starting point is at 0 degrees. So if our wind direction is, for example, 180, that'll make it go to a down arrow. I hope you see what I'm getting at here. If I go ahead and save this now, you can see it's actually just this massive icon, so we need to fix the sizing on it real quick. So let's go to the class name. Actually, we'll make a class name for it because there's not already one on here. Let's just give it a class name of size 8, just to be consistent with the other icons. And we'll also invert it to make it white. Now, if we save it, you can see we have a cool little arrow right here that points in the direction of the wind. So our arrow is pointing not quite perfectly downwards, but a little bit to the left of that. So it's probably around the 180 or 190 degree mark. If we quickly just go into our network tab, we can verify this. We just refresh the page, look at this call. Let's go to the current weather information, and we can see the wind degree is 184. So yeah, 184. So that's why it looks like it's almost straight down, but not quite. It's a little bit past. So it's actually really cool. Now we have the arrow that points in the direction of the wind. Having this arrow point to 184 degrees is way cooler than just putting 184. With that done, let's take a step back for a second. We've just successfully gotten API information from OpenWeather fetched through TanStack in 4 separate card components that each have their own unique styling and each subscribe to the exact same query that grabs this data. We've still got quite a ways to go before this app is finished, but we've made great progress so far, and arguably we've just knocked the 4 most important portions of our app out of the way, that being these 4 cards. So what's next? Now that we have our cards out of the way, I think it would be a great time to get the interactive map added to our app. All we really have on our page right now is just these 4 cards, which is cool, but by themselves they don't really do anything, and we don't actually have a way to change the latitude and longitude coordinates that we're getting our data from. Like this 10 and 25 here is just hard-coded, so it doesn't really mean anything if we can't change this and have it be dynamic. So what I'll go ahead and do is go into our components folder here, and let's make a new component, and we will just call it map.tsx here, and then as usual, tsrfc to create the component. And for this map, we've got quite a few different options for actually creating it. The library that I think is probably the easiest, at least for our use case, to implement is Leaflet. It's one of the most, if not the most widely used library in JavaScript for creating maps. And there is actually a nice package called React Leaflet that essentially wraps this entire Leaflet library and gives us super easy to use React components. So we'll use this for our app. If we're on the React Leaflet site and we go over to this menu, you can go to getting started, and there should be a step for installation, and it tells us how to get it added to our app. If we scroll down here, it should give us an npm command right here, so we'll go ahead and install this. The first command it tells us to run is this command right here, and we actually already have React and React DOM, so we don't need to run those again. What we will do is open up our terminal, a new one here, and we will just say npm install Leaflet, so we can get Leaflet added to our project, because Leaflet is a dependency of React Leaflet since it uses it under the hood. And then next it says to install React Leaflet add next. So we'll go ahead and install this, copy that, paste into our terminal, and now we should have both Leaflet and React Leaflet. The last thing I'll do just for convenience is to install the types, so TypeScript can be happy with some of this. So we'll take the Leaflet types and get that, And once we've run those 3 commands, we should be good to go. And then at the very bottom of this page, there should be this next setup button here. So we'll go to this page, and it actually gives us an example of what a basic map looks like. For the sake of just showing you what it looks like and how it works, I'm going to take this entire example actually. I'm going to copy it, and I'm going to paste it into our map component so we just have it in here. Then I'll make sure to import these components from React Leaflet. Get map container, tile layer, let's get a marker, and then pop-up. We will go ahead and save this file. I also think for right now, we actually don't need this pop-up on second thought, so I'm actually going to get rid of this pop-up, and I'm just going to make marker a self-closing tag here. So I'll just make it a standalone marker with no children. Right now, going back to our app real quick, the coordinates that we've been fetching for different components are just latitude 10 and longitude 25. So if we go to our map here, that's actually what these are right here, the center, this array right here that we use for both center and position. So I'm actually, instead of having these hard-coded numbers, just going to put in our 10 and 25 coordinates. So this position of the map matches exactly what we're already hard-coding. 13 zoom is a lot, so I'm going to change this down to something like 5, something way less zoomed in. And I also don't care about this scroll wheel zoom prop, so we're going to go ahead and get rid of it and save this file again. And until we actually get proper setup for our dashboard styling, the map that we have on the page is not going to have any actual width or height. So let's just give it something hard-coded for now just so we can see it. So I'll give this a, give this a width of 500 pixels. And I'll also give it a height of 500 pixels as well. Just hard code it. And now let's take this map component and let's go over to our app here. And let's put it above the current weather card. It's going to render out map just like this. Looks like the import isn't quite recognized. So I'm going to take this here. Copy it. This will be import map. And it should be export default, so it can be whatever name you want it. And then it should just be /components/map, just like this. And now it should be happy. And if we go ahead and save it, yeah, it's going to look pretty horrible. And this is likely because we haven't actually imported any of the CSS from Leaflet. So to import the CSS and make it actually look not like whatever the heck this is right here, let's go into the map component. And at the very top here, we're importing everything else. We're just going to add import leaflet/dist/leaflet.css, just like this. Go ahead and save it. And now this map should actually be somewhat functional and not whatever the heck we were just looking at. And this 500 pixel width is actually a bit small, so let's change this to be, I don't know, just 1,000 pixels, just so it's a bit wider. Go ahead and save it. And now we have a little bit more real estate to work with. So yeah, here's really what the map is, and this is, again, powered through Leaflet, the very popular library. The map doesn't really do anything crazy by itself, but what it does allow for is you can drag it, you can look around the map, you can zoom in, zoom out, see different city names. And it's actually supports a very high level of zoom, so I can go on individual streets here, and I can go out to the whole global level. It's actually a really, really cool mapping library. I've used it in a few things before, and I've never really had any problems with it, but I think it's quite a nice library to use. By default, it honestly looks and behaves very similarly to Google Maps, minus obviously a bunch of the complex Google functionality. So it's pretty cool though, actually with super minimal setup and just pasting in a command and changing some stuff around, that we're able to actually get a functional map like this. It's nice when these libraries and packages can do a lot of the heavy lifting. Something that is actually pretty cool now is this marker is positioned at latitude 10, longitude 25. So now when we're looking at our weather information and we see like the current weather and the forecast, we at least actually have a reference now to where in the world we're actually looking at, which is part of the point of even having this map in the first place. Here's the point in the video where we need to step up our game and start connecting everything together. Because right now, aside from being kind of cool, this map doesn't actually do anything. Nothing happens when you click it. It has no connection to any of our data or anything, aside from the hard-coded coordinates we're giving it. So a big piece that we're missing is connecting this map somehow to the cards, so that when we click on the map, it'll update the latitude and longitude to update the information on our cards. What I think we need to do next is hook into the actual click event of the map, somehow set some latitude and longitude state, and then connect that state to the query that we're making to actually get weather information for those coordinates. Because all we've done so far, every time we use this use query and call the get weather function, we're just hard coding 1025 in there, which, you know, is cool for testing, but it's not functional. So if we actually found a way to hook into the click event of this map, update some state, and get our query to reflect that actual weather information, that's the next big step that we're missing. So without wasting any more time, let's go ahead and build out that functionality. React Leaflet has a hook called useMap that allows us to get access to whatever map container that we're referencing. Once we have the map from useMap, we can hook into all sorts of events, control camera panning and zooming, and all sorts of other stuff. This useMap is what we'll use to hook into the click event. However, the main problem we're going to run into right away is that useMap can only be called if we're inside a map container. Otherwise, it's not going to work. The reason why we can't do that in this map component is because this map component, if we were to call, useMap up here, this map component is not wrapped inside a map container. Only the things that are actually inside of it would be. So the way I've typically handled this in the past is just creating a brand new component beneath this that I would just usually call map click, just like this. And then this component right here is where we would actually use the useMap hook. So we'd call it down here. We would get this imported from React Leaflet. And then because this component is purely for functionality for getting this map, we actually don't care about returning anything. So we're going to return null for this. And then inside of here, we're just going to render map click, just like any other regular React component. Now, because we're calling the useMap hook inside of a map container, this object that we're going to get back here, this map object, will directly reference the map container that it is inside. And basically, all we have to do now to actually hook into the click event to do what we want it to do is go down here, and we would just say map.on, and we can hook into the click event just like this. And then our event handler would be the second argument, which is a function. So we'll take in E and make it a function like this that will get called whenever we click the map. In other words, if I go in here in the map and I start clicking around, whatever function we have right here is going to get invoked on each click. Before we worry about the actual click functionality and setting any sort of latitude or longitude state, it would be cool if we added a pan effect. Meaning if I click somewhere on the map, we should make that click point the new map center. That way if I click somewhere on the edge of the map, like over here in France, the map will actually move over and shift to center the area that I just clicked. And there's actually a super simple way we can do that in this onClick. All we have to do inside of this function is type map.pan2, just like this. And the first argument that this pan2 takes in is an array that is just the latitude and longitude. That way the map knows which coordinates to actually pan to. How do we actually get the latitude and longitude out of our click event? All we have to do directly above this pan2 is we can actually get it from this E event here. It exposes the coordinates that we clicked on. If, just to show you, I go ahead and console log out E here, I'm going to comment out this pan2. We'll go ahead and save this. I'll open up our console right here. And the map's super tiny, but I'll go ahead and click somewhere. And if I click, here is the event. And you'll notice we have this property right here called lat longitude, or lat LNG. And it has the latitude and longitude coordinates that we just clicked on right here. So basically what that means is what we can do in the code is to get the latitude and longitude, we can actually destructure them. We can say const lat and then also LNG equals E dot lat LNG, just like this. And it's really that simple. Now this will be the latitude and this will be the longitude. So we can uncomment our pan2 and we can say lat longitude, just like this. And now it'll pan to wherever we click. If I go ahead and save this file, go ahead and refresh just in case. Now if I zoom out and I click somewhere, notice how when I click, it is panning to where I'm clicking. And it doesn't quite look centered actually because this map is way too huge. It's kind of overflowing the bounds here. So let's take it from 1,000 pixels and let's do 700 pixels, just slightly wider than it was before at 500. And that's a little better. So now if I click, it's a bit easier to see that it's centering where I click. So when I want to jump around the map, say I'm in Africa and I want to go to Italy, I can click here and it'll pan everywhere I click. And it's really just that simple to create a pan effect. Obviously, this marker that we have right here isn't changing yet because this marker is still hard-coded to this 1025, but we'll fix that in just a second. But now that we have this pan effect working, what's next? Let's get down to what we really came here to do. Inside of this click event on the map, we don't just want to pan to wherever we clicked. What we really want to do is set some latitude and longitude state of wherever we clicked. That way the other cards on the page can update their information to reflect those actual coordinates. The question is now, how do we even start by going about doing something like that? Well, the simplest way I can think of is by keeping track of latitude and longitude in the app component, so the most parent component, because it happens to be the direct parent of the map, but also all of our cards. Basically, what I'm saying is that if we're getting the latitude and longitude in the parent, and every component that needs it is just a direct child, it's actually super easy to do because we can just store it in app and then we can pass it down as props to each of the children. If you don't fully understand where I'm going with this yet, let me just show you firsthand and we'll work through it. First things first, we're not using this use query up here anymore, so let's just completely get rid of it. Then what we're going to do is make a new state for our coordinates. We'll say const coords, just short for coordinates, and set coords equals use state, just like this. And in terms of the type for these coordinates, we'll just make it an object. We'll just give it a lat property, which, you know, we've been using this 1025 number, so we'll keep using that. So let's say lat and lon, just like this, making sure to import use state. So basically we have this coordinate state and the setter function for coordinates. We're making a state in React, and we're just defaulting it to an object with default values 10 and 25. If we go to any of our cards, like current weather for example, we still have this hard-coded 1025 number. But now that we have this chord state up here, let's use that instead so they can at least all share the same state. So what I'm saying with this is we should take coordinates and pass it down as props to all of our cards down here. Now, if I had a ton of components and the complexity was a bit more in-depth than it's gonna be here, I would most likely use a provider and pass the coordinates down with a context. That way we're not drilling props everywhere. However, because these cards are the direct children of the app component and we're not doing huge amounts of nesting and, you know, huge component complexity, I think it's best for simplicity if we just do them as props. Because we're going to be seeing this type structure right here a lot of the object that has the lat and longitude property, what I'm actually going to do real quick is just go into source here. I'm going to make just a new file in here. I'm just going to call it types, and it'll just be like a helper function that we can export types from. I'm going to say export type chords, and we'll make it match the structure that we were just talking about. We'll have lat be a number, and lon, and longitude also be a number. And we don't really have to do this right now, but let's just go into app, and just to make sure, let's make sure the state is typed with type chords, just so we're being explicit. Now that we have this chords type, let's pass down chords to each of our cards. All we have to do for that, for each one, is we'll say chords equals chords, just like this. And because they're all going to be the same, let's take this, copy it, and paste it in all four of them. Again, like I said, if we were dealing with more complexity, I'd probably do this in a provider to prevent these props just being passed on everywhere, but I think this keeps it pretty simple for our use case. Now each of these will have a type error because they don't expect any actual props, they don't expect this chords yet. So let's go into current weather, for example. Let's go into the props here. And we'll just make sure to add chords as type chords, just like this. And we can destructure chords from the props, just like this. Now for our suspense query, instead of hard coding 10 and 25, what we can do now is just say chords.lat and chords.lon. So we can be assured that the coordinates that we're getting down in this component, this current weather card, are the same coordinates that are set in the parent. And we'll have to make the same changes to our other components to make TypeScript happy and to make sure this all works the way that we want it to. So let's actually take the suspense query. I'm going to go each of our cards here. Let's replace these suspense queries through an hourly. We'll do it in daily, and we will also do it in additional info. And then these will need the exact same prop structure as current weather. So we'll just take props here, also doing the same thing. Make sure these are all typed the exact same, because again, they're only all just taking in the coordinates. So we'll have this, and for each one, make sure we import chords here and destructure chords. So there should be additional info good to go. We'll make sure we import chords here in the daily forecast. Also destructure from here. Save this. Now this is good to go. Get chords out of here. Import the type. Hourly forecast should be good to go. And now that should be all four of them taken care of. Now all four of our cards are using a shared state from the parent. So we can actually go ahead and just, close out of these cards here. Let's go back to our app real quick, and we can see we've suppressed all of the type errors. Now, just to see what happens, if I go ahead and refresh this page here with our 1025 coordinates, actually here real quick, let me save this, refresh it, you can see it says we're at 76 degrees, 1246, whatever. So let's change this 1025 to something else. Let's make it 4055 instead. And now if we do this, go ahead and save it, all of these cards just changed. I can do it again, let me just show you. I'll do this 5045, and now every single card just shifted because now they're all using the exact same coordinate state. They're not just a bunch of hard-coded numbers coming from nowhere. Now that we did this, step one is complete for connecting the map and these cards. The next step would actually be, logically, to get this same coordinate state passed down to our actual map. Because right now we have this marker that's on the map, but the marker doesn't mean anything. It's not really coming from anywhere. So ideally, the map actually needs the same coordinate state because it needs to know where to place this little blue marker at. So what we can do in map is the same thing as the other ones. We can give it a type chords, and here in our props, destructure it. And instead of using center 1025 and position 1025, I'm gonna actually destructure here to make it a bit easier. We'll say lat lon equals coordinates, Get these out of here. The 10 will just be latitude. The 25 will be the longitude. So now the map is also using our shared state, and we'll just be sure to actually pass this down in the same way we're passing it down for our other cards. We'll go ahead and save both of these now. And now if we look over at our map, it looks like our marker has moved over here to somewhere in Russia. Now that that's taken care of, and the map also has respect to the same latitude and longitude coordinates, let's take care of the important part. And that's setting up the latitude and longitude coordinates once we actually click the map. So basically, utilizing this set coordinates function. So what we'll do in our app here is let's make a new function. We're going to say const on map click, make it a function, and we'll just make it accept two arguments, latitude, which is a number, and longitude, which is also, of course, a number. What we're going to do is we're going to define this on map click function up here in the parent. We're going to pass it down to the map, and then we're going to call it in the map whenever we do the click event. The reason for that is the state that we want to update is up here on the app level. But whenever we call it, we can just pass in the appropriate latitude and longitude from the map click event. So that's where these arguments will get passed in. So inside of this on map click, all we need to do for right now is just say set chords, calling the setter function, and we're going to set it to lat and lon, just like this. So basically, whatever we pass in for our latitude and longitude will be what the new coordinate state gets set to. Now the question is, how do we actually get this on map click function to get called in the click event of the map? Well, like all the other things, we're going to use props. So we're going to go to our map here. We're going to add an on map click prop, and we will just pass in this on map click function. Go ahead and go to the map here, and let's add on map click. We know it takes in two things. It's just latitude and longitude, both numbers. Doesn't return anything, so we'll just say void. Now if we save both of these, we're passing on map click down, and now in map, we have the ability to access it from our props. So let's go ahead and destructure it just like this. And then we'll also have to drill this on map click down to our map click component so we can actually use it in the click event. Normally, I would say prop drilling is a bad thing, but if it's only 2 layers and it's only for a single thing that you're doing, it's really not that big of a deal. If I was going deeper than 2 layers, definitely I'd use a provider and pass it down through context. But for now, we'll just make things simple, and we'll also give the same exact prop to our on map click. So we'll drill it down to this component here and make sure that our map click expects on map click, which is just of type. That's actually the exact same type up here. So I'll just go ahead and copy this. It'll be on map click, just like this. And now we've finally done it. We've actually arrived at the click event with our on map click function. So now all we need to do is actually just call it in here, right below our pan-su. All we'll do is call on map click. And again, we know the signature is taking in a lat and a longitude number as 2 separate arguments. So easy enough. We already have those 2. We'll just pass in lat, comma, lon to get latitude and longitude passed in. And now we've actually done it. Our map is fully connected to the click event where we will propagate this data back up to the parent, which will update the coordinates. So let's test it out. If I actually save it, refresh this to be sure, and click it, we're going to notice something. It looks like nothing is actually happening for our cards. The state actually is getting set properly, but nothing seems to really be happening in terms of the state update. So let's test something really quick. Let's go into app here, and let's just add a console log, and let's log out our coordinates here. Go ahead and open up our console. Close out of all this. Oops, not the console itself. I just wanted to shrink this down. So let's close this. Let's just click somewhere on the map. You can see we have our latitude and longitude coordinates right here. If I just, scroll in this little tiny window over here, expand it a tiny bit so it's easier to see. I click here. You can see if you look in our console, it actually is updating the coordinates. So it looks like the state update is going through, but for whatever reason, our cards don't actually seem to be updating. And there's actually a very simple reason for this and super easy fix. Right now, all of our cards, like current weather, hourly forecast, whatever, all have the same query key. It's just the string weather. However, generally a huge no-no with tan-stat query is that whenever you're passing in dynamic values to your query function, like we are for example with the coordinates, because these can change, you want to make sure these coordinate values are included as part of your query key. Because what's happening right now, since these all just have this hard-coded weather query key, is when we click somewhere on the map, it adds that weather key to our cache, and then we click somewhere else, and it sees the exact same key, even though our coordinates changed. So it just uses the data that is already there, meaning we're always going to be stuck on whatever the first cached value is. That's why you usually add these dynamic values like coordinates to our query key. That way it knows to update with each one. In other words, if the query key is always static, the cached value in the tanstat cache is going to be treated as static as well. When I say this fix is super simple, it is. All we have to do is in our query key, add coordinates to it like this, a fresh query key for each time we click somewhere. So we'll go ahead and take this, we'll actually save it, and we'll go into each of our cards and make sure that all of them expect that exact same query key. That way, they're all not static anymore. Go ahead and get this one, and we will get additional info for the final one right here. And now, if we go ahead and just close out of all these cards, and we go back to our map, and I click somewhere, boom, all these cards are going to update now. I can kind of scroll to the bottom here so you can see a bit of the current and the hourly. You can see if I'm clicking somewhere on the map here, these cards are updating in real time. So that's super sick because honestly, in a really short amount of time, we just got our map hooked up to all of the cards. So now all of the components that we're seeing on this entire page all share the same value context. No matter where I click on the map, every time I go somewhere, looks like it lags a little bit sometimes, but every time I click somewhere, these cards are going to update completely. So we actually already have a huge chunk of functionality of this app knocked out of the way. If I want to know the weather information for, I don't know, somewhere in Japan, let's say Tokyo, I can go here, and I actually, forgive my geography here, I don't know, I think this is Tokyo here. Can select this, and you can see this is the weather information for that particular city. If I want to go, I don't know, I'm curious to see what the weather looks like in London, and scroll over here. Go to London, click here. Okay, it's in a bit of lag there, but we have 44 degrees, and we can see the hourly forecast, the daily forecast for the next week, and all sorts of additional weather information. So that's super neat. Now that this functionality is out of the way, what do we want to tackle next? The next thing that I like to do is add a location picker dropdown. It's super nice being able to use this map and click anywhere you want to get the exact weather. But as you saw, sometimes I want to know the weather for a particular location or city like London or Tokyo. So what I think would be neat is above this map here, having a drop down that we could click that would have a list of pre-populated popular cities. So instead of having to zoom in the map and find it, I can just open the drop down, click wherever, and it'll get the weather information for that particular city. However, creating a fully functional select component that is styled great and works exactly like you want it to may take quite a bit of time building from scratch. Which is why right now, instead of building our own custom select, we're instead going to use shadcn for some of their pre-built components. If you're not familiar with shadcn, essentially it's just a component library that allows you to install components as needed. Not some library where we install 10 gigabytes of packages or anything crazy. We can just import some pre-made components like these ones into our app. If you want to build your own custom components just for the sake of learning, that's completely fine, more power to you. But for this video, to save time, we're going to use these pre-built shadcn components. For example, if I go to the view components here, I can find the select component, and if I look at this, it's a drop down just like this. Pretty much already coded for us. Obviously we can put our own data in there, but the component is already essentially made. This is going to save us a lot of time, as opposed to trying to code all this logic in-house. While there obviously can be unique use cases where you need to do your own thing, I think it's important to not reinvent the wheel, especially if you want to keep things consistent. So in our use case, we'd have a drop down like this, we would click it, and there'd be a list of cities here that we can click, and when we click, it would update our map and all of our cards. The way that shadcn works is for each component that you want to add to your app, basically all you have to do is just run this command right here, this npx shadcn at latest, and you just add whatever component you want to add. And then from there, you can actually just render out the component like this. They have a bunch of examples, but essentially you just import the stuff from the component, and you can put your own content inside of it. However, before we do that, we need to make sure our project is set up to add shadcn components, because there is some setup required before we can actually run this command. If we go back to the menu up here, and we go to the installation page, go to Vite, should be the default there, and there's already some commands here, create the Vite project, which we've already done, tailwind CSS, we already have it, so let's move on to this step down here. First things first, it tells us to edit our tsconfig.json file, so let's go into our file explorer here, go to tsconfig.json, and it wants us to add these compiler options right here, right underneath the references array. So we'll take this compiler options, take it like this, and add it right underneath references. Go ahead and save it. And next it says to also edit the tsconfig.app.json, so we'll go to that file as well. And we already have the compiler options here. We just need to add this base URL and paths here. Let's copy this. Let's actually go to the very bottom here. Actually, let's see, compiler options ends here. Okay, so let's go inside here. and just add it right here. Make sure to have a comma so it doesn't get mad. And now we have this added, so we'll go ahead and save this file here. And next, all we got to do is get these types installed so we can actually resolve our file paths whenever we try to import the components. So we'll take this command, open up our terminal, copy paste it in there, go ahead and run that. And then the very last thing I think that we need to do before we can start adding components and we can initialize the project is just to add some stuff here to our vite config. So if we go to our vite config file, it says that in addition to having the plugins here that we have, so we already have, React Tailwind and SVGR, we need to add this resolve object right here. So let's just copy that, go here, paste it, and then this path should just be imported directly from path, just like this. And now if we save it, we should be all good to go in terms of our own files. Now that we have all these, to actually get shadcn in our project here, all we need to do is run this command right here, this npx shadcn latest init. So what we'll do is we'll take this command here, copy it, go into our terminal, and we'll go ahead and paste it in here. Didn't quite copy and paste, right? So let's make sure it just runs this. And it'll ask if we're okay to proceed to install shadcn. We'll say yes, of course. It's going to ask for a color palette. For this one, we'll say zinc. I like zinc quite a bit, so we'll go ahead and select that. And then it should install the dependencies and get the rest of it set up. And now we should be good to go. Now let's actually go back to our page here. Let's go ahead and refresh it. And just to make sure everything is actually fresh here, let's restart our Vite server. So I'm going to go Control-C this, npm run dev again. And now if we save it, go back to our page here, notice how all the styling suddenly looks pretty bad. These cards have a bunch of dark text now, and now the background of our app is white for some reason. And that's because if we go to our index.css file, when we initialize shadcn in our repo, shadcn added a bunch of different variables to support the zinc color palette. So we have things like background, foreground, cards, popovers, all this stuff, that it added some of this predetermined styling to our page, so that's why it looks a little funky. Let's fix this real quick before we add the select. In our index.css here, notice how we have this card variable. This card variable is actually exactly what you think it is. If we have cards on a dashboard, we want them to use this color instead of just some random other hard-coded color. So what I mean by that is if we, let's just close out of all these tabs here, more room, we open up card.tsx, go to here. Right now it is just background zinc 900, but if I instead change this to bg card and save it, now this is actually going to match this card variable that we defined in here. Now, however, what we've just kind of done is switch from working in an app that was pretty much in a dark mode configuration to a super bright and just white app that's, essentially just light mode. We're going to add a toggle later in the video to go back and forth between light mode and dark mode, but for right now, let's go back to the dark scheme that we had before. All we have to do is to go into our index.html, and if we go to this body tag right here, all we have to do is add class equals dark, just like this. And if we go ahead and save it, now we're back to the dark theme. And this is something that's actually really cool about shadcn that I'll explain in way more detail when we actually do the light mode and dark mode switcher. But basically what shadcn does is we have this variant here for dark, which checks the body for having this class dark on it. And if that's the case, what it will actually do is instead of using all these variables, which these variables are defined for light mode, it will actually use variables defined down here specifically if we have dark mode. So now, instead of using this card right here, which this card right here is just white, it'll actually use the dark card right here, which is more of a zinc color, which is why we see this color over here of the dark color, not the light color. Because this dark selector is a dark class selector, and on the index.html, we do have the dark class. Again, I'll explain this more once we get into our light mode and dark mode switcher, but for now, we're just going to have it hard-coded to dark mode because I think it's easier to work in. I just prefer it. I don't want to get too sidetracked from adding the shadcn components to our app, but real quick, something that I think would be super cool to add is to make these cards look a little bit more reflective. So right now, they're just this solid color, but one thing you can do that can kind of make stuff pop out a little more, in my opinion, is instead of just doing a solid color background, if you instead do a gradient, so I'll do bg gradient to br, meaning a gradient going from the top left to the bottom right. And then a neat little trick I like to do is when you do gradients, to start it from the card color and actually have it go to the same card color, but with slightly less opacity. So we'll say, I don't know, /60 for this. And it looks like if you hover this, it's giving us a warning. I'm curious what this says. Can be rewritten as bg linear to br. So, okay, let's try that. Must be a new Tailwind thing. So I'll go ahead and save that. And now our cards, I think, look a little bit nicer. It's a very, very subtle change, but it makes the cards, in my opinion, look a bit cooler. It just looks a little bit brighter at the top left than it does in the bottom right. Now that we've got these colors looking good, let's get back to the whole reason why we added Части into our app in the first place, to add the select box for particular locations on the map. So if we go back to Части and we go to the component menu, which you can go here, go components, we can find select again. Let's scroll down to where the command is to add the select. Looks like it's this command right here. What we're going to do is we're going to take this, we're going to copy it, open up our terminal, and just run that exact command. Not sure why for some reason this copy and paste seems to be acting up, but do that. And once you run this command, it'll actually install the select component and just the select component from Части into our repo. What it does that's actually pretty cool is it will go into your repo and it'll look for a folder called components, which we already have. And if you have that already existing, it'll make a new folder called UI, and this is where all the Части components go. So now you can see we have this component, select.tsx in here, that is just the Части select component. Now that we have this, we're free to use it however we please. And if we look over here at Части, it gives us a perfect example of how to actually use the select, just like this. What we're going to do is we're actually going to take this right here, we're going to copy this to our clipboard. I'm going to go over to our file explorer, and inside of our components folder, I'm going to make a new folder, and I'm going to call it dropdowns, because we're going to have, I think, 2 dropdowns in this app, not just one, which I'll explain in a second. But I'll make a new file in here that I'm just going to call location dropdown.tsx. This is going to be for our map. tsrfc as usual to create this component. And now that we have this example over here from Части, we have it copied. So let's now paste it into this component and get all these imported from UI/select. Now it's kind of annoying because you'll see the add import from Radix UI, but all these are going to be imported directly from our own UI folder. So we'll do here, select content, import select content here, and then just import select item. And now this component should be good to go to at least test. Now what this is this select trigger component right here is essentially just the button that triggers the dropdown to open and close, and select content is the dropdown itself. So for example, over here, if we go to this button you're seeing that says select a fruit over here is the select trigger. Now the select content is what actually gets dropped down right here. And we have all this just wrapped in the select component. Now that we have this file saved and we have this component, let's go back to app.tsx here. And directly above our map, let's actually render out location dropdown over to our page. And let's go ahead and save it and give it a good old refresh. And now you can see up here at the very top left is our dropdown, and in its raw form, it looks something like this. And it actually looks like it's getting cut off quite a bit by the map because the map's just covering it. One thing I've noticed for some reason with Leaflet is that sometimes the maps that you use have a z-index of around 1,000 for whatever reason. So to have the dropdown to show over the map for right now like we would expect, let's just go onto the select content here. And let's just give this a class name, and we'll just say Z1001. I generally like to stay away from spamming z-indexes everywhere, but sometimes you gotta do what you gotta do. So let's save this, go back, and now you can see it's opening up over the map, and this is what it looks like in its raw form. Now let's get some real content into this dropdown. Obviously, we don't want light, dark, and system because that has nothing to do with what our dropdown actually is. So let's get some cities added to this. I just went over to ChatGPT real quick and asked it to give me an array of really popular and well-known cities, and this is what it gave me back. So instead of just having some random values in here, let's actually use these cities to put inside of our dropdown. The way that we can do that is just to wipe out what we already have here for the select items. Let's make a JavaScript expression in here, and we're just going to say locations.map, and then for each location, actually let's call it a city. For each city, we want to map over something, and you want to return the same select items we were using before. We'll just do it like this. And you want to make sure, because we're mapping, that we have a key here. So we'll say key. Key will just be the city name because these should always be unique. And then all these need a value as well. And the value will also be the city, which also will be what we're putting inside the select item here. So that's what the user sees. Now if we go ahead and save this, go back to our page, click on this. Now our drop down is full of our cities instead of whatever random stuff we had before. So I can click on Tokyo, Dubai, London, whatever I want to click on, and our dropdown is actually looking pretty cool. Now what's next? Well, unfortunately, when we're making these calls to open weather to get the weather information, it only accepts coordinates in latitude and longitude. So if I select Tokyo, for example, how do I have any idea what the latitude and longitude coordinates of Tokyo actually are? I need to have some way to convert city names directly into latitude and longitude coordinates. Luckily, that's exactly something that OpenWeather has support for. It's called the geocoding API, which you can just get to at /API-geocoding API. Basically, what this endpoint does is it takes in the names of countries, cities, states, or whatever, and can return latitude and longitude coordinates that match. If we look at the way to call the API, it's actually pretty simple. All it really needs is for us to pass in this Q parameter right here that can be the city or state name. If we go to the actual API response fields, you can see here once we pass in, for example, a city name, here's what we'll get in return. We'll get a name for the local name, in those particular languages, and then what we actually want, the latitude and longitude. So we just spit in the city name and we get out the coordinates. So what this implies is, much like how we're doing the fetching from the one-call API for the weather information, we'll do the exact same for a function that calls this geocoding API. Where we did that originally was in the api.ts file. So let's go back to this, and all we'll have to do here is make another function, just like getWeather, that calls this particular geocoding endpoint instead of the one-call endpoint. So what it will call, if we scroll up past this, let me actually minimize this here. What it will actually call is this URL right here. What we'll do here is we'll go into api.ts, we'll make a new function, we'll say export async function, we're going to call it getGeocode, just keep our naming conventions pretty similar. And inside of here, just like the other one up here, let's actually take this, let's copy and paste it in here, but instead of using this link, the same one we're using for getWeather, let's take this exact link right here. So we'll go ahead and copy it, and let's paste this in to our string instead of that. We'll do this, paste it in here, and now let's modify this to be what we want. As you can see here in the docs, it says this Q can be a city name, state code, country code, whatever. We don't really care about all that. All that we're going to do is a city name. So that's all we really need. So basically, in this call here, where we have that, we're going to replace this whole chunk here, this whole Q equals chunk. We're just going to replace this with $, brackets like this, so we can inject something, and we're just going to say location, which will be an argument that we pass into this function that will just be a string. So for example, if I go into our dropdown and I click something like Tokyo, that will pass Tokyo as a location into this function, which will then get the latitude and longitude for Tokyo by passing it in here. For this limit right here, let's just hard code it to 1. Reason being is you can get multiple in the form of an array. I don't really want that. I just want one match because I think it's sensible enough to assume there'll only be one source of information for any given city. And then just like the other one where we have this app ID, we're just going to plug in our API key just like this. So we'll add the $ here and we'll do API underscore key. And now we're passing our API key through to this API. The only last thing to do is we're already converting it to JSON, but what we're not doing is parsing it through a correct schema. We're still using the same schema as the weather information, which obviously we don't want because the response structure is different. So let's make a new schema. Luckily, the schema that we're going to have for this is actually super simple and easy. I mean, there's only a couple of fields here to actually take into account. So what we'll do is we'll go back to our File Explorer here. We have the schemas folder. Let's make a new one. We're just going to call it, geocode schema.ts, just like this. And then we'll need a Zod schema that matches this return shape from OpenWeather. I'm again trusting my good friend ChatGPT here to generate me the schemas. Basically, all I did is just took this exact response shape from OpenWeather and asked it to make me a Zod schema, and this is what it spit out. And if we just quickly look at this, it looks like it's correct. I mean, we have name, which is a string. Lat and lon are both numbers, obviously. Country is going to be a string, and state's also going to be an optional string. And then local names we're not really going to use, so it doesn't really matter, but this does look to be correct. Now that we have this schema, much like we did for our weather information, we'll parse that schema. So if we go here, all we have to do is say geocode schema.parse the data, and we actually should be good to go now. If we save this, this function should be ready to take for a test drive. If we hover over get geocode, you can see the response type is a promise because the function's async, and it just has this structure. So we know we're going in the right direction. All right, now let's hook up this API function into Tanstack query and get this ball rolling. If we just close out a few of these files real quick, just to free up some space here, we head back into app. We already have a use state that stores our coordinates. Let's make another use state that stores the location that we've selected in the dropdown. So if I go here and I select Dubai, we should have a state that now holds Dubai. So what I'll do is I'll say const location, set location equals useState, and it'll just be a string. Let's just default it to Tokyo. We'll assume Tokyo is always the default starting point. And then to geocode using that function we just wrote, all we have to do is write a use query in here. So we'll say const get data out of here equals use query. And like any other use query, we need a query key and a query function. For the query key, let's say it is an array. We'll just say it's the string geocode, and we'll also pass in the location. Because again, like I showed you with the weather information, we want to make sure if our query function is going to consume location, which it will, we need to have that be part of our query key. Now we just need the query function, which is the function that we just wrote, which we called, I believe it was get geocode. So we will call it like this so we can pass in arguments. And if we go back to this, remember this just expects one argument, a location string. So we'll go here, pass in the location because it is the string. Just like this. Now this query should be good to go. Now if I go ahead and save this, we can actually see what's going to happen. If I go over to our console here, let's go to our network tab so we can see the request. Let's just go ahead and refresh this. You should see that we have this one call, which is from the actual, the weather information we've been working with. But we also have this other call right here, direct. And this is the response that we're getting from the geocoding. So we can see if we look at the headers, it is the geocoding one. We're passing Tokyo in the request URL here. If we go to response, we go down to latitude and longitude, boom, there they are. Jackpot. So now we know that we can pass in any city name, at least any city name that OpenWeather recognizes, which it definitely should recognize all the major ones. And we know the response from this geocoding API will give us the coordinates of wherever we want. And that is going to be huge because as we know, our weather information requires numerical coordinates, not just names. So now we can use these coordinates that we're getting back from the geocoding. Now that we have the latitude and longitude from the geocoding, that means there's two possible spots these coordinates can now come from. Either they come from the geocode API, if we click on a city from the dropdown, or they're coming from the map click if we're looking for our own custom location. What that means is that this chord state right here needs to accommodate for both. How do we know whether we should use the coordinates from the geocoding, so from the dropdown, or whether we should use it from the map click? An easy way to do this would be to check and see if this location string right here is actually a city name. My thought is what we can do is in the on map click, we can set location just to custom like this. Because every time we click on the map, we know we're not finding the information for a city from the dropdown, so let's just set it to custom each time we click it. What this will allow us to do is define which coordinates we want to pick. If it's custom, use the map coordinates. If it's not custom, use the geocoded coordinates. And that's how we're going to differentiate them. So down here, what we can do is let's actually rename this chords to just be coordinates instead. Because we're going to redefine chords down here as a derived value. So we're going to say const chords, and we're going to make this a ternary. We're going to check the location, and we're going to say, okay, if the location is equal to custom, then what? If it's custom, we know that we're coming from a map click and not the dropdown. Therefore, we should just use this coordinates value up here. So let's say if we're on custom, use coordinates just like this. Otherwise, if we're not on custom, that means we click somewhere on the dropdown. So let's use those instead. And I just showed you if we go to the network request, again, just so we can double check this. If I just, let's close out of this real quick, refresh, and I look at one of the geocoding calls, we have the object, and then we have the latitude and longitude. So if we click somewhere from the dropdown, instead of using coordinates, which is for the map, we can actually do is set this equal to an object and just say we want this to be latitude, and the lat comes from data. It's an array, so it'll be the 0 index there, and then lat and lon. So lat's going to be data at the 0 index dot latitude, and then the longitude is going to be data at the 0 index dot longitude, just like this. And because data can be undefined, we'll technically have a type error here saying possibly undefined. Let's just add a question mark dot to this, just so we suppress that error. And now what we're saying with this coordinates, the coordinates that we're passing down to our components, is that we're either going to use the coordinates from the map, or we're going to use the coordinates from the geocoding, which is from the dropdown. However, now because we added this question mark dot here, it's going to say that our coordinates can possibly be undefined, so it's going to throw a little type error here. What we can do in that case is we can say if these are for whatever reason undefined, let's just make them both fall back to 0. This way, they're at least always going to be a number. And that should make everything happy. So if we save it and refresh, that should make our map return. And it looks like we keep getting this error kind of crashing our page here, and it's a Zod error, saying that for the weather information, it's expecting wind gusts to be a number, but it's undefined. Let's go to that schema real quick. We go to weather schema, look at wind gusts. It looks like this can maybe be optional because we're getting undefined for some of them. So let's just add optional to this. Go ahead and save it, and hopefully that should fix our page crashing issue. Just make sure it won't freak out for a second. Hopefully it shouldn't. And there we go, seems to be fixed. And before we do anything else, just so this code's a little bit more clear on what we're doing, let's not just have this be data. Let's actually rename this to, we'll say geocode data, just so it's obvious that whenever we're getting this latitude and longitude, it's coming from the geocode in case you're reading it over. Now we have just one more thing to add. We're setting location to Tokyo by default, and we're setting it to custom whenever we click anywhere on the map. But one thing we're not doing, which is arguably the most important part of this dropdown, is actually setting any state when we click one of these. So if, for example, I go in here and click London, nothing actually happens on any of our cards or anything because, well, I'm not setting any state on the clicks. To give context to our dropdown on what the current location is and how to set it, let's actually pass down both the state itself and the setter function as props, meaning the location and set location into the location dropdown. So what we'll do is we'll say location equals location, and then set location equals set location, just like this. Our location dropdown doesn't expect those props right now, so let's go into that component and we will go ahead and add them. So we'll say location is going to be a string, and then set location is just going to be a type of dispatch set state action. This is how setter functions are normally typed in React, and it is setting a type of string. Import dispatch from React. And then these should be good. Now we can pull both the location and set location out of here as props. To make sure our select knows what value it should be displaying is, we can just go into the select, we can give it a value, and make sure the value is just set to whatever our current location is. So it's either going to be a city name or it's going to be custom. And then we can take a step farther, and on this same select, we can give it another prop that is just on value change, meaning each time we click one of the options, what we can do is we can get the value out of here. So basically whatever we clicked on, and this value right here is going to be the value of whatever's clicked. So for example, if we click London, because we have the value equals city here, this value will be London. So what we can do now is use the set location prop we just passed down, and we can say set location with whatever value we just clicked on. Meaning if I set, for example, Dubai in this dropdown, now that will set the location state in app to Dubai. If I now go ahead and save it, we can actually see this directly in action. You can see, first of all, now we're actually hovering right over Tokyo. If let's just zoom out a little bit, I want to go to Dubai, boom, our information updates. If I want to go to Rome, again, our information updates. So each time I'm doing it, you can see the data changes. And that's because we're switching which city we're fetching data for by clicking an item in this dropdown, since we're now setting the state. However, there's immediately one problem that I'm noticing. The main problem being that whenever I select a new city from this dropdown, nothing happens with the map. It looks like the data updates right away down here, but the map just stays exactly where it was. It never changes. And I think the way we can fix this is actually super easy. We can just do it in a one-liner. We know that whenever we click a location from the dropdown, the coordinates are changing no matter what. So if I have Dubai selected and I click London, we know the coordinates are going to change. And we know that when the coordinates change, the map component is going to re-render to reflect the coordinate changes. So why isn't this map updating? Well, what I would presume is that if we go into the map component, I would guess that because this map container is kind of just a generic wrapper around the vanilla JavaScript library of Leaflet, it might not consider this center right here changing to be a valid enough reason to trigger a re-render. So we can actually do it manually. A little hack I like to use to force component re-renders is to throw a key on it. If the key of a component changes, React is 100% going to re-render the component. What we can do is on this map container, we can actually throw a key on it, and let's just make this a string. Let's just do, I don't know, chords.lat, comma, chords.lon, just like this, just so it's a string. This way, we can be 100% confident that whenever coordinates change, this string right here, this key string is going to change. Therefore, the map should re-render. So if I save that now and I refresh just to start clean here, and I click on one of these items, now our map should go to wherever we're wanting to go to. And it looks like now it's working, our map is re-rendering. However, I'm sure you're noticing this little problem here, this flickering thing. Anytime we go somewhere, it flickers to, looks like, the middle of the ocean first, before it goes to wherever we're actually wanting to go to. I'm noticing a potential problem actually now with this key approach, because if I click a location on the map, it's always going to re-render the entire component no matter what, which is going to force that little flickering that we're seeing. And this happens really no matter where we go, because this key that we have is actually forcing the re-render. So now we're always just going to be flickering, which is honestly super annoying, and we don't want that. So let's rethink this key approach. I think I've got an idea. Let's remove this key from here, and instead of re-rendering the entire component, let's just call the map.panto function that we have right here directly in the component body of mapclick. After all, we know the only way that mapclick can re-render itself is if coordinates change, because coordinates would be a prop. So what I'm saying is, what we can instead do to fix this little issue that we're having is we are already getting the coordinates passed down here. What we can do is we can actually also pass coordinates down to the mapclick. So let's pass chords like this. Let's make sure we get chords out of this component. And we'll say the chords are of type chords here. And let's actually take this map.panto out of the click. So we'll move it up here. And instead of using this lat and longitude, we don't have those anymore. Let's just use the coordinates directly. So we'll do chords.lat, and we'll also do chords.longitude. And actually, it's not longitude. It should be, I believe it's just LON. Now, what I've just done with this is I have made it so that whenever the coordinates change, now mapclick is actually going to re-render itself because coordinates are a prop. And we know in React, whenever props change, a component re-renders. And the reason why it's fine to have this map.panto in just the component body and not actually in the click event or in like a use effect or anything is because this map should only ever re-render when the coordinates change. And if that's the case, mapclick will also only ever re-render when coordinates change. Therefore, we assume that anytime that coordinates change, we need to pan to a new location anyways, so it's fine to just run this code in the component body. In fact, that makes more sense and makes it less complicated than having to do something like a use effect, which I generally caution against. Now I can show you because I just saved it. If I refresh this, we start in Tokyo, let's go to somewhere on the map, click, and boom, now we get the exact behavior you want. No more weird flickering thing happening on this page. If I go here, select something like, I don't know, Manila, notice how this case, we actually are still having a bit of a flicker. Only when we select something from the dropdown, but not when we select a custom location. The reason this is actually happening and we're getting this weird flicker effect is that because when I click on one of these locations, it is immediately setting the location to the new string. So when I click somewhere, it's immediately setting location and this updates right away. However, the problem is this getGeocode function is asynchronous, meaning it takes some time to actually resolve it. So basically for a split second after we set location, this is still running, it's still in flight. So the actual geocode data that has latitude and longitude is undefined. So basically for a split second, we fall back to 0, 0 for our coordinates because we have this fallback here. And then it becomes defined. So that's why it's causing the flicker. So if I click somewhere here, let's refresh it. I go here like London, it's going to flash for a second because it falls back to 0, 0. And then it resolves and then goes to London. So it's kind of this really weird flashing issue, but it makes sense why it's happening. However, we're not going to fix this quite yet. We're going to address this once we take a look at the skeleton loaders. Once we set up proper suspense boundaries and skeleton loaders, this shouldn't be a problem anymore. Let's move on to the next thing. There's one more thing I want to add to this map real quick to allow it to give us way more information than it currently is. If we go back to Open Weather, one of the APIs that they have that you can access for free is called Weather Maps. If we go into the doc for Weather Maps here, there's something actually really cool that we can do. So over here, you have the map of the world, and they have different types of map you can layer on top of your existing map. So for example, a cloud layer would look something like this. Precipitation layer, sea level, wind speed. And there's a few different layers I think that if we added to our app could make it really cool. And this actually is not nearly as hard as it might look. This is super easy and we can get added to our app very quickly. Basically all we have to do is in here, it gives us a URL that we can use. It's this URL right here. We can actually just copy this URL directly. And what we can do is if we go to our map here, we can add a new component in here. So we have this tile layer here that's doing our actual map. We can actually just make another one of those. We can say tile layer, just like this. And in the same way this has a URL, let's take same thing, URL equals this. we'll use backtick characters and go ahead and paste this in. All we need to do now is to pass something in here for our actual layer and then pass in our API key. And it's really that simple. So if we go to the api.ts file, we have this up here. That's how we got our API key. Let's actually take this exact thing and add it to the top of this file. So we'll say API key. And in this tile layer, we'll use that same API key just like we have for everything else. The API key, just like this. And now we just need to look at this layer right here. If we go back to the docs, it says that layer is the layer name. By layer name, what that is this. So for example, the cloud layer is just clouds underscore new. Precipitation layer is precipitation underscore new. So those are the layer names we need to pass in to this layer right here to get the actual layer that we want. So now the question is, how do we know what to actually pass in for this layer here? After all, we're inside of our map component, but we have no context of knowing what layer the user wants to see, especially if we want to support all these different layers. Well, what I was thinking is, we already have a drop-down to select the city for different cities across the world. What if we just use the exact same component and do the same for map type? What I'll actually do for this is I'll go to our drop-downs folder, and when I said there'd be another drop-down, this is what I was meaning. We'll make a new drop-down. We will just call this map type dropdown.tsx. And I'm actually going to take all the code pretty much verbatim from location dropdown. I'm just going to copy it. I'm going to paste it in here. And we'll just make sure to rename this one to map type dropdown. And then instead of taking in location and set location, we'll just say map type. And then this one here is just going to be set map type as such. And we'll make sure these just get those out directly. Let's make sure this is also map type here. Rename everything. This is set map type. Then we can actually get rid of these. These are now redundant. And now we essentially have functionally the same dropdown as we have for the cities, but now just for map types. If I go and save this right now, I'm going to go and add it to our app here. We'll just go pass in map type dropdown. Now let's go down here and we have locations, but obviously in here we're not calling them locations anymore. Let's just call this new array types. Instead of having a bunch of city names here, let's just put the types that we're getting from open weather. So again, I think there should be 5 types in here. Let's just copy each of these down. So we have clouds new. Actually, we'll just, this whole thing here, copy it, paste it. So we have clouds new. We have precipitation new. We have pressure new. Wind new. And I think this is the last one, temp new. So now here's the types that we are mapping over. And it's as easy as that. Now we have a functional dropdown that can set a map type state on each click, just like we're doing for the map location. What I'm going to do here is I'm going to go ahead and save this file. Let's go back to our app here. And just so we can render out both the map type and the location dropdown, we're going to Control-Shift-P around this div here, around this dropdown, wrap it in a div, and we're going to give it a class name of, let's say, flex gap 8. That way we can render out both the location dropdown and the map type dropdown side by side. The only thing left to do now is to create a state to hold our map type, just like we're doing to hold our location. So what we'll do is actually we'll take kind of this same format here, copy it, paste it. We're going to call this map type right here, the map type, and then this will be set map type as such. Because the very first map type that we see in here, I believe, is clouds, or should be clouds new. Let's make that our default state. So let's say, instead of Tokyo, we'll make this clouds new. And then because we made our dropdown the very same format as we did our location dropdown, we can just pass in map type like this. That will be map type. And then set map type is the exact same thing. And now our dropdown is happy. Let's go ahead and save this file here and look over. And now we should have both the location dropdown and the map type dropdown. What's nice about using these reusable Chatsien components is that once you get the component set up for one use case, getting it set up for the next is super simple. As you can see, getting this map type thing was pretty self-explanatory. So because we copied the exact same format, now we know that whenever we click one of these items in the dropdown, we are setting this map type. And this map type is what we need to pass down to our map to plug in to this layer right here. So let's go into map here, and we'll actually add that to our props. We'll say we want to pass in the map type, which is going to be of type string, and then we will destructure that from our props like everything else. And then instead of passing in layer right here, we can add a $sign and inject the map type directly. And now we're all set. It's really that simple. So I'll go ahead and save it. And I'll just be sure to now pass in the map type to our map. Oops. Auto formatting's a little weird. Pass in map type like this. Save it. And look at this. We just got a layering over our actual map that has, for right now, the precipitation. If I want to do it as the clouds, boom, here's what the clouds look like. We can do pressure. This is what pressure looks like. And we have super easily just created another layer on our map to show some more information. Super, super cool. Every single one of these gives me a new unique map. And what's really cool is you'll notice, because both the tile layers that we have in map, so meaning the actual map itself that's right here, and the layer for the clouds or precipitation, pressure, whatever, because they share the exact same parent and the way they're positioned, if I zoom in, notice how everything still stays in the correct spot. It's not like when I zoom in or zoom out, the actual, layering of the wind is going to change and shift around. They all stay relative to each other. So whether I'm grabbing and moving around or I'm scrolling in and out, they should always stay in the same spot, which is exactly what we want, because that's how map layering should work. One thing, however, we should fix real quick is the names in this dropdown. The OpenWeather API needs the names in this format right here, but if I were a user and this is the format of the strings I saw, I definitely think it's a bit weird design, right? Because if I want to see, a wind map, I don't want to just click on wind new. It doesn't really make a whole lot of sense. To make these say their actual names and not this whole, API format of names with an S underscore new, whatever, we can actually, let's close out of these tabs here. And let's go back to our map type dropdown. We can actually do a little bit of a trick here. First of all, we can throw a class name on select item here. We'll throw a class name and we'll add capitalize. That way we just capitalize the first letter of each thing here. So now if we go into this dropdown, the first letter should be capitalized of each one. And now for this trick I was talking about, the names we want to display to the user should ideally just be the part of the strings that come before the underscore. For example, precipitation underscore new should just say precipitation. Pressure underscore new should just say pressure. Basically on each one, just get rid of the underscore new. So for what we're actually displaying to the user here, which is this value right here, we can do something super, super simple. We can say .split, and we want to split the string on the underscore character. That way it will split it into an array. So for each thing, if we have, for example, clouds underscore new, this city.split at the underscore will make it an array with the first string being clouds and the second one being new. And since we only want the first part of that string, we can just take it at index 0. Meaning if clouds new is what this city is, this will split it and will only take clouds. So now if we go ahead and save it, look at here, it just says clouds, precipitation, pressure, wind, and temp, just the way that we want it. What's cool with this method of doing it is that the user is going to see the actual names here, but whenever we click one of these, the value is still just the city. We're not doing any sort of split on this, so the API still has the correct value for it. The user just sees something that's a little bit more formatted. And now, what this means is that we have a fully functional map layer dropdown that allows us to stack different map layers on top of the existing map. I can see where any clouds in the entire world are, what the pressure is like, what the precipitation is like, and you get the picture. The last thing I want to do with these dropdowns before we go hands off is just a slight modification to the location dropdown. I noticed a second ago that whenever we click a custom location on the map, that it just blanks out the location dropdown up here. And that's because whenever you do a custom location, this doesn't match any city name. Because whenever we set custom location, we're setting it like this. And because we're plugging location into our location dropdown, just like this, as the value, it's going to see custom, and custom doesn't match any of these, so therefore it just goes blank. A super quick fix for this is inside the location dropdown here, outside of where we're mapping over locations, we can just make a one-off select item. So we'll make a one-off just specifically for a custom. So we'll say select item, just like this. And actually, no, it can't be self-closing. It'll have to be like this. It'll say custom, and then the value itself will actually be custom. And this doesn't need to be an expression. We can just have it be a raw string. And basically, we'll only render this out if we're on custom. So we'll say if location equals custom, then we render this. Otherwise, don't show it at all because we don't want it in there. So now, if I go ahead and save it, now it should say custom in here. If I select an actual name like London, there's no custom in here, but as soon as I click somewhere on the map now, boom, it shows custom in the dropdown. I think that's a bit more helpful to the user than it just blanking out because it looks like an error happened or something. Lastly, just so the user knows which dropdown is which, let's put a label by each one. So let's go close out of these, go into our app component here, and we have this div surrounding both dropdowns. What we can do is take each one of these dropdowns and let's wrap each of them in their own div. So we'll say wrap, we'll do div here, and for this one, we will say the class name is going to be flex gap 4, and right above the dropdown, let's just make an h1 for the actual label itself, and this will just say location. And we'll do the exact same thing for the map type dropdown. So we'll go here, Control Shift P, wrap it a div, give it the exact same class name as such, and we'll take this same header, and instead of saying location, it'll just say map type, just like this. Now if we go ahead and save it, boom, we have some labels for each one. Let's do a bit more styling on these headers. Let's say for these, we'll give it a class name of, I don't know, say text 2XL, and then font semi-bold. That looks quite a bit better. Let's just copy that and put the exact same thing on the other one. So we'll take this whole class name, put it on here, and boom, now we have this for both. And I'm actually zoomed in a bit on my browser right now, so let's zoom out so it doesn't do that weird wrapping thing. Let's zoom out so it looks more like this, which puts other cards a bit more in perspective here. And then now that we zoomed out a little bit, actually, I want to change my map to be a bit bigger than it was. So let's go back to our map. And now let's see if we change it back to 1000 and see if it looks good again. Go ahead and refresh this. And yeah, there we go. This looks quite a bit better. We're going to get to some more detailed styling later on, but until then, we're going to leave these dropdowns alone because they're actually working great right now. I can select any city I want, get the location and everything for that city and all the weather information. And on top of that, I can see it for map types you want for any sort of map layering. So I have the freedom to do quite a bit, which means we've honestly come a super long way since the beginning, but we're not quite done yet. The next thing I want to address also involves the map. And for right now, it's pretty clear that this default looking map, like this kind of Google Maps looking thing, I don't think looks very good considering the color scheme of our site. Like this is all kind of a dark mode, you know, the zinc color palette that ShadCN selected. And having this like Google Maps, like greenish blue, just does not blend in with the rest of our app at all. This map right here is just the default map from OpenStreetMap, but if we want to get a fancier looking one or one that matches our theme a little bit more, we can use a service called MapTiler. If we head over to openmaptiles.org and then we scroll down, there's this dark mode map we can use right here that I think would look really cool in our app. It looks something like this. So it's this dark mode theme that I think definitely matches kind of this color scheme way more than this, you know, this default looking one does. So let's get this added to our app. To add a map like this, we'll first have to install the SDK for MapTiler. We can actually do that pretty simply by going into our terminal here and running the command mpmi, and it's going to be at MapTiler / leaflet, that's a leaflet extension, MapTiler SDK, just like this. If we install this, oops, looks like we forgot the in on npm. Let's run that back. Add the in here, and now it should actually install the MapTiler SDK. Now we can close this and go back to our map component. To add this custom cooler looking map to our map component, it's going to be made easier if we have access to the use map hook, just like we do within the map click component. So instead of rendering out this tile layer right here that's just doing the default tile layer, let's make a new component down here that we're just going to call, say, function map tile layer, just like this. It won't take in any props or anything. This component will be super simple. Just like map click, we're going to make it return null because it's purely for functionality, not for actually rendering JSX. We'll do the same thing that we're doing up here by using the use map hook. We'll say const map equals use map. And to mount this tile layer properly, we can use a use effect. So we'll say use effect just like this. Make sure we import use effect into our code. And I generally caution against using use effects, but when interfacing with straight JavaScript, like in the case of this tile layer here, or interfacing with external libraries, it's generally okay to have a use effect. The way we can display this new cooler looking map is if we make a variable inside of this use effect, say const tile layer equals new map tile layer, just like this. And that's going to be from the SDK that we just installed. This will be a function that we can call. Inside, we pass in an options argument, and it needs two options on here. The first one is style, so the actual type of map that we have. And an easy one that actually looks really similar to this map you're seeing right here, but is actually quite a bit more lightweight than it and will be a little bit faster, is just one called basic dark, just like this. So we'll see what it looks like in a second, but we'll use this for our style. And the second argument it needs is an API key. Just like OpenWeather, MapTiler wants you to use an API key if you're accessing its custom maps. And don't worry, you don't need to enter in any payment information or anything. It's completely free. You just need an account to get an API key. On MapTiler's website, so over here, all you need to do is log in, which I will just do now with one of my Google accounts. Once you're logged in, you can just go to this menu here, go to API keys, and you can generate an API key. Once you have this key here, just go ahead and copy it. And then we go back to our options here for MapTiler layer. All we have to do is say API key, just like this, and pass in the string you just copied. Now that we have this, all we need to do is use this new tile layer component. We'll just say tile layer and call this method called add2. And this is where we pass in our map. So I'll just pass in map, just like this. It'll just add this layer on top of our map, making it look like this basic dark style. So let's save this, get a little bit of formatting here. And when working with use effects, especially that involve external libraries, it's almost always a smart idea to have a cleanup. So what we'll do at the very bottom of this use effect is we'll just say return. And on return, you're going to say map.remove layer. And you want to remove the tile layer as such. That way, we're just being safe with how we're adding this tile layer to the map. That also means that dependencies of this use effect would simply be map. Now that we have this, let's go ahead and save this. And instead of rendering out tile layer up here, like I said before, like this is the default tile layer that we're seeing that's getting the Google Maps kind of look. We're going to replace it now with map tile layer, which, like I just said, will now supplant this map tile on top of it to give it that new look. So if I go back here, save it, boom, now our map is dark. As you can see, this matches our actual theme a lot better. I am noticing though on this particular layering, so the clouds layering, these pretty bright white clouds are looking kind of harsh against the map. It's kind of covering up a lot of space here. Like I can't really see anywhere in Europe right now. So what I'll do is actually go to this tile layer that we have here that we're doing for the map type, and we can actually add an opacity on it, one of the props it supports. And let's just do 0.7 maybe. That makes it a bit better just so it's easier to see, not quite so bright. And just for the sake of experimentation, if we click through some of our other map types, this is what they now look like against this dark backdrop. So it still looks really, really clean. And like I said, I think it just looks way better and way more kind of in place than the other map that we had was. Okay, now right now at this point, this is pretty much, for the most part, a fully functioning app on its own. We have map interaction that's hooked up with data queries. We've got map layering with different weather types, the ability to see all sorts of different information, and a few other things. A lot of the hard work is done. There's just a few more things I think we can add to this app to make it even better, along with polishing up what we've already got. With that being said, what's the next thing I think we should do? I think we should do one final thing with this map before we just stop touching it forever. To finish it out, I think one thing that would be good is adding a legend, showing what each of these colors mean. Because for example, if I go in here and I go to the pressure map, I really have no idea what this pressure map even means. I mean, I can assume that the darker colors probably mean higher pressure and the lighter colors mean, lower pressure, but I really don't have context as to any sort of units or what I'm actually looking at. Most maps that look like this with some layering generally have a legend to show what numbers each color represents. If we go back to the documentation for the Weather Maps 1.0 that we're using, up here there's this map styles legend, and it says we have default styles for weather layers. So if we click on it, it'll actually take us to this page here that I can zoom out a little bit. But basically, it gives us the actual legend values for each different map type. So for rain, snow, clouds, whatever, these are the actual numbers you could use for the colors. What this does is gives us an actual quantitative way to make a legitimate legend. It's essentially just giving us the color spectrums that we can use for each different map type. Not gonna lie, I'm too lazy to do this on my own, so I'm gonna take all of these numbers here, each of these objects, plug them into ChatGPT, and ask it to make me one big record that has all of this data in it that we can use to make our legend. So let's go ahead, open up our file explorer here, go to components, and let's make a new one. We will just call it maplegend.tsx for our legend, tsrfc to make the component, and I'm going to paste in what ChatGPT actually generated, which is this kind of massive object right here. This might look like a ton of complicated data at first, but it's really not too bad. It's basically just one big object here, or a record, where the key for each thing is just a string, which is the map type, and then the value is just another object that has some more information, like the title of whatever we're looking at, the unit, and what the stopping points are for the colors. And we have this for each map type. So we have one for precipitation, we got one for temperature, clouds, and you get the idea. The title we'll use to just display something for each legend, the units so we can actually have a unit number, and then the stops are how we're going to generate the gradient for what the legend actually shows. And of course, I could have done this by hand, but I promise you that ChatGPT can make this map type data record way faster than I ever could, so I'm happy with it. The first important thing that we'll need in this new map legend component is the actual map type. Since we have this big record of map type data, we need to know which map type we're actually looking at for our legend. So just like we're doing for the map itself, let's pass the map type down as props. So we'll go in here, we'll say map type just like this, and that will of course be a string, and then we will extract map type out of the props. And now to get the corresponding data for the legend, because we have this big record already, all we have to do is say const data equals map type data at any given map type. So for example, if we pass down a map type of precipitation new, then this data is going to be equal to this whole object here because we're referencing this map type data at that key, so we get the value. Now we just need to build out our gradient for the legend. One of the ways that we can do this is to map each stop point to its color and also exactly where it should be on the legend. So to do that, what I mean by that is down here below data, let's make a new variable. Let's say const gradient stops. It's going to be equal to data.stops. So we're just grabbing this array here. And for each one we want to map. So we're going to say .map. And then we'll say for each stop, what we want to do is we want to make a template string since we're plugging this into CSS. And we're going to say stop.color just like this. However, for gradients to work right in CSS, when we have a bunch of them together, we need to give each gradient a position that is percentage based, meaning the bottom value should be at 0% positioning in the gradient, and the top value, for example, 140 for precipitation, should be at 100%. And that goes for all these different types. This first entry here will always be the 0% point for the gradient, and the last one will always be the 100% point for the gradient. Setting the percentage position for each stop is how CSS knows where each color is actually going to go. The way that we can do that in here where we're mapping is right after we're doing our stop.color, we can actually separate this by a space, and we'll do another expression here. And the way that we can actually get the percentage is by doing the current value divided by the max value. That will give us exactly where we are. Let's first find the max value. We know the max value for any given set of stop data is always the value of the very last array item. For example, for this stops here, we know the highest value is always going to be 140. For temp new, we know the highest value is always going to be 30. Luckily, the way ChatGPT generated it and the way it was in the open weather docs goes from lowest value to highest value, so that makes our job quite a bit easier. What that implies then is that the max data, we can say const, we'll call it const max value, equals data.stops, and it's going to be data.stops.length -1 to get the very last one, and it's going to be that value. So exactly what I was just saying. And now what we can do in this expression is in here, we can simply say stop.value divided by max value. We're going to multiply that by 100, and that whole thing is going to be a percent. So this might look a little bit wackier, this whole gradient stop thing we're doing, but basically all it is for each stop, we're just generating valid CSS that we can use for the gradient, which is this whole string here. This first expression, this first point, is the actual color of the gradient, which we have here with each of the stops. And the second value is at what point in the gradient it should actually be, which is this. And that's always going to be a percentage. So if we take, let's say for example, we go down here to clouds. This is easy because they're all, 0 to 100 here. Let's say we take this 50 value. Well, for this particular gradient, we're going to say the color is this because we're just mapping over stop.color. And then we're going to take, going back to 50 here, we're going to take that value, which is 50 divided by 100. So we do 50 divided by 100, which is 0.5 times 100, so that's 50%. So essentially, that particular value is this RGB code here, this 247, 247, 255, and it's going to be at position 50%. That's what this thing is doing here for every single gradient. You'll see how we can use this whole string in just a second. The only last thing that I need is to convert this entire thing to a comma-separated string. I can't give CSS just a JavaScript array of strings. It won't do anything. It needs to be comma-separated. So to turn this whole mapping thing, this whole array that I just made essentially, into a string that is comma-separated, all we have to do is do .join, and we're going to join it at the commas. And now we should be good to go. Let's finally use this and get it implemented in our JSX. Let's scroll down here till we have our JSX, and right now, actually, it's up here. Right now, we don't have anything. It's just this div. So let's wrap this in parentheses here. And for this outermost class name, let's give it just a couple of things. First, we'll make it be position absolute, and then we're going to say top for and right for. The point of having this positioning is that when we render this out, it'll be in the top right corner of the map. We'll also give it the same z-index of our map, so we'll say z1000, and also just width 48 to make sure it has a quantitative defined width. Let's now render this out and just see how it looks. So we'll go ahead and save this file here, go to our app, and what we'll do is we'll take our map here, and let's wrap this whole map in a div. That way the map and the map legend can actually share the exact same parent. We'll map this in a div here, the space for the formatting, and then let's give this div a class name of relative. That way whenever we position our map legend absolutely, it positions itself relative to the parent. And now right below our map, we'll just render out map legend as well, just like this. Make sure we get it imported. And we still need to pass in the map type, so we'll do the same thing there. We'll say map type equals map type, just like this. And now if we save it, you can see obviously our map legend doesn't really have a whole lot going on because there's, no styling here besides saying map legend. But we do see it say map legend here at the top right of the map, so it is there. Now that we know it's showing, let's get this JSX in order. So again, I'll wrap this in a parentheses. It's kind of annoying that Prettier seems to want to reduce this to one line when you do a save, which is a bit of a complaint I have with it, but is what it is. So what we'll do first on this div here is we'll throw a couple of things on it. First, let's do rounded XL. Let's also give it a shadow and some padding, and let's give it a background color. Luckily with shadcn, when it exposes some of those CSS variables, one of the ones it uses is background. So let's actually do BG background. And I don't want it to be 100% opaque because I don't want it to necessarily block the map behind it. So we're going to do /50, so it's 50% transparent. Go ahead and save this now. You can see now we have this little view. Lastly, let's give it a tiny bit of a border for even more separation. So we're going to say border, and then for the actual border color, there's also another variable that shadcn created called accent that I think will be good for this. So we'll say border accent. We'll also make this not fully opaque. We'll make it slightly transparent. So we'll say /70. Now save it, and it sticks out a bit more. This will be more noticeable when you get to light mode, but that creates just a tiny bit more of a separation from the actual map itself. And now, instead of doing width 48, I actually want to change this to width 96. And now that we have that, I think this will be good to go for this outer div. Now, in terms of what we want to put in the JSX here, it should actually be pretty simple. First thing we'll do is we'll put a title at the top, then the gradient bar below it, and then the values at the very bottom. Just 3 simple things. We want this in a column layout,